leading cause of death. And in every year, 1.19 people die due to road accidents. Most of the accidents are related with the children and the young adult people, and most of the deaths are related to the vulnerable road users. If we will look into Indian scenario, then as per the report of road accident in India 2020, uh, in 2020, more than 4.6 lakh accident were happened, in which more than 1.6 lakh people died due to accident, and also the more than 3.4 people are injured. The accident severity is 36.5%, and most of the deaths are related to the fatal accidents. And these accident these accidents are most of the accidents are happened at the T junctions, and in those accidents, uh, about 44,000 drivers are killed and about 22,000 passengers are killed. So due to these reasons, it is important to conduct the hazard perception study and also provide training to the drivers in different hazard scenario. So that's why in our present study we have created two hazard scenarios such as static and dynamic, and we have investigated the investigate the relationship of visual performance of the driver in both the scenario, and also we have considered the gender and the experience effect. So to create the scenario, we have used fixed back desktop simulator, and this simulator is our department. And to record the Toby Pro glasses, to record the visual performance, we have used Toby Pro glasses 3 eye tracker. And for this study, we have recruited 65 participants, in which 15 participants are female and 50 participants are male. And all these drivers are holding valid license. And we have also classified these driver as a inexperienced and experienced driver. And all the parties normal and normal vision and the hearing. So to create the scenario, we have selected 8-kilometer stretch in NH 953 from Netrang to Rajpipla. The road features was two-lane undivided rural road with varying gradient and sharp curves. And we have also created two hazard events you can see in bottom of the picture. So the dynamic hazard is pedestrian crossing, and the static hazard one is roadblocks present on the roads. And before starting the data collection, first we have briefed the participants about the our experiment and the studies. And the steps for the data collection is comprises in three steps. First one is training module. In training module, just we have just briefed the participants about the hardware of the our simulators and also the purpose of the study. In familiarization session, we just provided them to simulator, just drive the simulator and learn about the hardware of the simulator. And finally we conducted our own experiments. So and these are the eye movement parameters we extracted from our recorded eye tracker data. So we have extracted first fixation duration, distance from the hazard zone during initial fixation on the visual attraction, mean fixation duration, number of fixation made by drivers, and the pupil diameters. After the extraction, we have analyzed our data. So for the analysis, we have conducted two-way ANOVA test, and in two-way ANOVA test, we have conducted two cross two mixed design. So first design was conducted in between type of hazard and the gender, and second design is conducted in between type of hazard and the driver experience. And all these tests are conducted at 95% significant interval, and all the tests are two-tail tests. And from their analysis, there are some results we have achieved. So in gender, it was observed that female generally made a longer fixation duration. So we can say that female take long time to perceive any kind of hazards, and specifically it was found that they took more time to perceive any hazard in the dynamic hazard scenario. And it was also identified that ki female engage in more fixation on hazard than males. So it showed that ki female take longer time to scan the hazard type. And in terms of experience, it was observed that experienced driver have shorter fixation duration and greater initial distances and fewer fixation than noise driver. It indicate that ki, it indicate that experienced driver are more efficient. Experienced driver have more efficient hazard processing than the novice drivers. And from this, we can also say that novice drivers require additional noise driver require additional visual processing and attention as compared to the experienced drivers. So based on these our research, we can say that ki gender and experience affect how drivers perceive the hazards. Female drivers are longer and more cautious looking pattern, especially for the dynamic hazards, and also experienced driver react faster as compared to the novice drivers. So these findings can improve driver training program. Training can now focus on teaching driver to spot and react the hazard faster, and make the road safer for everyone. And also tailor training for novice and female driver in specific hazard can improve the hazard perception skill. This approach helps reduce accident risk and promote safer driving by building on different strengths across the driver groups. Along with this research, our transportation system engineering groups also they are conducting more research, such as some of the our PhD scholar conducted research on distraction driving. Some of they are working on sleep deprivation driving. Some of they are working on distraction due to billboards. Also, some of them are working on optimization of bandwidth in controls coordinated control signals. And these are our faculty in civil transportation system engineering groups. And I would like thank you to my professor and civil engineering department IIT Bombay and the IRC to give me the opportunity to present my work here. Thank you.
Well within time.
Yeah, thank you, Mr. Suraj. It was really need of the hour to focus on this aspect of safety. Uh, Now I welcome Mr. Mohan Kumar, who will be presenting on methodological framework for identifying passengers or subjective comforts, focusing on lateral clearance. He is a fellow from Civil Engineering Department of Indian Institute of Technology, Bombay.
Hello all. Good morning. And I am Mohan Kumar Somavarapu from Civil Engineering Department. I am joint PhD scholar and PMRF. I am working under the supervision of Professor Avjit Maji from IIT Bombay and Professor Nanjing from Monash University. Today I am going to give presentation on methodological framework for identifying passengers subject to comfort, focusing on lateral clearance. Coming to the highway geometry design, conventionally, the design has been made by using the three major parameters, which are humans, vehicles, and roadway and their interaction. However, from the human's point of view, only drivers are majorly considered by taking the physiological and psychological factors. And from the vehicle's point of view, dimensions and their capabilities are considered, and the roadways, the various types of roadways and their pavement surface conditions are considered. Uh, uh, Coming to lateral gap maintaining behavior, different drivers behave in different ways, and they will while traveling in a road, based on their comfort levels or their experience, they will traveling at different lateral clearances, which are especially from the dynamic moving objects or any stationary objects which are on the road. And passengers comfort, which can be defined as a state of ease from stress and anxiety, and which especially arises risk from the observations and the judgment of the surroundings. Passenger comfort generally depends on two different kind of criteria. One is catered by the car manufacturers, and the other thing which is called as a navigational ride or traffic factors, which will be depending on different parameters like vehicle behavior or the environmental conditions, which should be catered from the driving situations. And from the literature, it can be studied using different subjective measures, which are started from the questionnaire survey and Likert scale rating, a think alert survey, and in percentile. My main objective of this presentation or this work is to understand how the passenger's comfort is varying from different situations and to identify some threshold where it is different from each other. A methodology for that first data collection has been carried out in the National Highway 548, and it is a two-lane divided with 36-kilometer stretch. And this is the ego vehicle setup to collect all the vehicular parameters like distance from the surrounding objects and to collect the surrounding environment and speed of the objects. Data collection has been done using 5 participants, and it can be seen here the participant setup. Participants are requested to sit in the rear right position since it is an two-lane undivided road, and asked to give the rating based on their comfort level while traveling on a road. So they are giving out their comfort rating from 1 to 7, which is 1 is feeling of comfortable, and 7 is especially extremely discomfort. The data extraction phase next started in the lab, which uses this VBUC test suite and the Trobu Pro, where the different details of ego vehicle speed, target vehicle type, and the rating has been observed from the recorded videos, and the later clearance is also extracted. These are the concentrated target vehicle types, and by seeing these vehicles, the passengers has given the ratings based on their comfort levels. Coming to the analysis and results, overall 5 participants were participated here, and it is around 104 minutes of data has been extracted with the total number of events which were rated by the participants of 543. This is a small attempt to understand the data. Here, the rating has been drawn on the box plot where it can be seen with the different coordinates. Here, there is small pattern can be observed from car, LCV, and the HGV that as lateral clearance from the vehicle is increasing, the passengers' comfort levels are also increasing. Where the lateral clearance with the particular target vehicle is more less, then the passenger is feeling more discomfortful. However, there is no good reasonable trends here because the effect of the ego vehicle speed also. So to understand that the average rating given by all the participants has been summed up, and it is observed here. For the car, it can be clearly seen that for the lateral clearance of 0 to 1 or 1 to 2, it is near to 3, which is uncomfortable zone, and it also depends with varying the speed of the ego vehicle also. As the speed increases at the same lateral clearance, the passengers are not feeling that much comfortable. Similarly, the results can be seen for the LCV and HGV. Later on, the binary logistic regression has been used. Since the rating has been collected on the 7-point Likert scale, it has been converted to the 2 points 0 and 1. The base point has been considered as an 3. 3 and below is considered as a 0, which is comfortable zone, and 3 and above is considered as an discomfortable zone. And using the binary logistic regression, the results were analyzed. Here, the green color one are the significant results. It can be observed here. The threshold for the less speed, whenever there is a less speed with respect to particular vehicle category, less ego vehicle speed, the passengers are accepting at the less lateral clearance. However, as the speed increases and the vehicle type is also changing, passengers are not feeling that comfortable compared to the previous one. And these are few of the conclusions. On-field study has been carried out, and this methodology can be used further also. And the variation in the speed also showed that there are with respect to speed, there is a variation in the comfort levels, and this threshold can be used for enforcing the speed restrictions and revising the road width based on the passenger's comfort level. Because till now, conventionally, we are using this driver behavior as in study. We are moving towards an automation, and several industries are manufacturing the self-driven vehicles and vehicles without drivers, where the passengers are the crucial. These are some selected references. Along with this study, we are conducting other research works in modeling domain from different faculties in our department. And I would like to acknowledge my department faculty members for supporting me and giving this opportunity. And I would like to thank IRC. Thank you.
Thank you, Mr. Mohan Kumar, for such a lively presentation. Now, I'd like to invite Mr. K. Rahul Chandra. He is IIT Bombay PhD student. He will be presenting on an automatic curve radii extraction algorithm using naturalistic driving data.
Yeah. Good morning, everyone. I'm K. Rahul Chandra. I'm a second year PhD student in Transportation Engineering Specialization, Department of Civil Engineering, IIT Bombay. I'm working under Professor Avjit Maji. So these are the contents of the presentation. And the introduction is uh, roadway departures are more likely at the horizontal curves due to the change in the road geometry, which affects the drivers and their driving behavior. So to reduce this roadway departure crashes, implementing safety countermeasures such as dynamic curve warning systems, rumble strips, and minor roadway design improvements can be done. So for this, since the curve geometry is more important to get the vehicle speed and acceleration, deceleration, and the trajectory. So the curve geometric details should be extracted prior to that. So the traditional methods of operating the road geometry are as from the as-built drawings and the manual surveys. In case of as-built drawings, most of the road details are not available in the database. Even if available, there is a significant difference between the existing road geometry and the whatever there is in the as-built drawings. So even if available, there is one more constraint, that is it takes a lot of time and effort to extract it in the form uh, that can be used for the modeling and analysis. So, and in the other case of manual surveys, it is time consuming and risky for the surveyors to get the data from the on-site when there is an ongoing traffic, and the cost of data acquisition and man hours increases when the scale of the study expands. So to reduce this manpower and the time in the geometry extraction, it is essential to develop an approach that can identify the curve geometry with acceptable efficiency and accuracy. So this is the brief literature review of the curve geometry extraction methodologies. It has been divided into two major types. Those are software-driven methodologies and the instrument-driven methodologies. In the software-driven methodologies, there are methodologies related to GIS maps, AutoCAD digital maps, and satellite imagery. In case of instrument-driven methodologies, all the naturalistic driving methodologies are included. And these are the steps involved in the geometry extraction methodologies. Those are the road centerline localization, curve detection, and the road feature extraction. In the road centerline localization, the identification of the centerline points of the curve uh, are is performed. These are done using the kinematic methods, average calculations of the to and fro trajectories, and the GIS applications. In the curve detection, the curves and tangents are identified using the bearing calculations, AutoCAD maps, and the GIS applications. In the road feature extraction, the final curves, geometry of curves and tangents are extracted. Uh, this is extracted by using the curve fitting and using the GIS applications majorly. And from the literature review, these are the inferences. Among all the studies mentioned, geometric details opted from the GPS method was found to be most efficient and accurate, followed by the plane sheet method. In addition, when the quantity of the section is analyzed in the higher number of quantity are higher, the GPS method was found to be economical and easy to use and safe. And in the literature, researchers has found that the GPS and GIS-based methodologies were most economical, and LiDAR-based methodologies were least economical. So, objective of the study, even in the GPS-based studies, the survey vehicle is instrumented with a GPS module, and the drivers were asked to follow the particular lane or to drive in the naturalistic way. In the naturalistic way case, consideration of the driver behavioral aspects was ignored, and in the second case, it was difficult to maintain the particular path for the driver if the number of curve sections are higher. So to minimize that, so this study makes an attempt to develop um, a methodology that can extract the geometric details of the horizontal curves using crowdsourced data. So this is the methodology of the study, in which the inputs are vehicle trajectory data that includes that includes the GPS coordinates and yaw rate. So yaw rate is the rate of change of heading angle with respect to the vehicle's vertical axis, and this is the variation of the yaw rate. It is constant along the tangent sections, and there is variation in the you are in the curve sections. And in the process, there are two major steps. That is a curve identification and geometry extraction. In the curve identification, um, two parts are the GA star statistic computation and the clustering of the transition points. This is a GA star statistic. It is a spatial statistic tool that can cluster the spatially higher values and the lower values. So it is basically a z-score value which which gives the which clusters the higher values and the lower values based on the confidence interval. And so with this, the curve points will be identified, and the positive here in this figure, it can be seen that the uh, positive z-score values are the right turns, with and the blue ones are the uh, negative values, which are the left turns. So with this, the curves are identified, and the start and end points of these curve points are called as the transition points in this study further. And the clustering of the transition points. So these transition points are clustered to get the start and end points of the curves, which is performed using the density-based clustering, that is density-based spatial clustering for applications with noise. So it is a two-parameter model, which is the unsupervised clustering method, in which the two parameters are required, epsilon and the minimum number of points. Um, and the epsilon value is estimated using by determining the k-distance plot. And the medians of these obtained clusters are computed to get the start and end points of the curve. So the final stage is the geometric extraction. In this, the 5 curve points are extracted by joining the obtained start and end points in the curve identification, and those are equidistantly uh, that is divided equidistantly, and the perpendicular bisectors are drawn towards the curves, and the 5 point clouds are extracted, and the medians are found to get the curve points. In this process, only the left turn trajectories are considered, since the drivers tend to maintain less lateral deviation in the left turns rather than the right turns. And the curve fitting to get the curve radii, extracted curves radii. So this is the objective function. So the method of least squares is being used, and this is the objective function and the constraints of the this method. And the using the output using the discussed methodology by giving the input of the Nashville driving data trajectories. The curve radii of the different curves are extracted, and the validation of this methodology. So um, the proposed methodology is tested with the naturalistic driving data available in the IIT Bombay, which is the origin and the destination of the data collection is from the Tokawati to Malchechghat, which are 20 kilometers apart, located in Maharashtra region. And 35 drivers data in both to and fro are used in this validation. And in some cases, like if there is a bad road condition and there is a poor data quality, those data points are ignored in the process. And when the GA star statistic is computed and the Z-scores distributions is observed, so it looks like this. And in this plot, we can see that the left turn curves, the 99% of confidence interval with the lower values are considered as the left turn curves, and the higher values are considered as the right turn curves. And using this GSR statistic, the curve points are the transient points are of the curves are identified. So one curve's start and end points from the different trajectories are shown in this figure. So these transient points are clustered by determining the epsilon value using the k distance plot as shown in this figure. And finally, the curve points are extracted using the by getting the perpendicular bisectors, and using the circular fitting as shown in this figure, the curve radius are extracted. Using this methodology, 33 curves were detected automatically, and the values are validated, checked with the actual radius, and found that the RMSE value, root mean square error value, was 8.29 meters. Mean absolute error value was 6.45 meter, and the MAB, mean absolute percentage error value, is 5.7 percentage. The conclusions of this study: this methodology considers a single behavioral aspect. Yeah, future scopes of the study. This methodology considers a single behavioral aspect of lane deviation of the roadways, considering more aspects such as the speed of the vehicles, such as and the perception and the negotiation of the curves based on the driver's factors may possibly reduce the error, which can be further considered as a future scope. And the other parameters of the horizontal elements such as the curve length, deflection angle, and the tangent length can be extracted. Applications of this study, practitioners can be used the proposed methodology to extract road geometry based on the road length to be estimated and geometry features to be extracted and the efficiency required. Moreover, an inventory can be developed uh, using this model to evaluate and improve the safety and mobility of the highways. And these are the other ongoing research projects going on at our transportation research group. And these are our transportation systems engineering faculty. We thank our faculty and the department for providing this wonderful opportunity. Thank you.
Thank you, Mr. Rahul Chandra. That was really a great presentation. So now I invite Dr. G. Gurunath. He's already done his PhD from IIT Kharagpur. He will be presenting on a new approach for determining rejuvenator for designing bituminous mixes with reclaimed asphalt pavement material. Dr. Gurunath.
Good morning to one and all. So the research work which I am going to present today is the extension of my PhD work. So for the sake of continuity, I have summarized my previous findings in 2 to 3 slides. So after that, I will directly jump into the current topic. So we all know for the design of bituminous mixes with reclaimed asphalt material involves the determination of the allowable RAP content as well as the fresh bitumen content that needs to be used in the production of the hot recycled asphalt mixtures. Whereas the allowable RAP content needs to be determined from the blending chart. In order to use the blending chart, we are supposed to extract the binder and test its physical or rheological properties. Based on the rheological or physical properties of the RAP bitumen, the target binder properties, the fresh bitumen grade can be determining using the blending chart as shown in the slide. So for the determination of the optimum binder content, aggregate gradation and bitumen content of the RAP material is required. Several research studies has reported the problems associated with the current solvent extraction recovery method, in which actually complete solvent recovery from the bitumen is not possible, which will in turn affects the properties of the bitumen and influence the selection of the allowable RAP bitumen content as well as the selection of the regenerator dosage. So moreover, most of the contractors are not equipped to perform these studies in the laboratory, and moreover it is time consuming. So there is a need to develop an approach with which actually practitioners can determine the allowable RAP bitumen content with the basic equipment that are available at most of the field laboratories. By keeping this point in the mind, actually our study has proposed two simple performance indicative tests which can be carried out with the basic equipment that are available at the most of the field laboratories. One test which we have proposed is the fragmentation test, another one is the cohesion test. It can be seen from the figure that fragmentation test is an impact test which can be carried out using the modified Proctor setup, which is available at most of the laboratories. Fragmentation test involves subjecting a single size fractionated particle into a series of impacted load in a confined mold at different test temperatures, and thereafter measuring the percentage of material that is passed through the control sieve. So the fragmentation value is nothing but the sum of the percentage of material passing through the control sieve for all aggregate fraction considered at a particular temperature. The index which we have proposed from this particular test is the fragmentation slope, which is denoted as the x frac. So fragmentation slope is nothing but the slope of the linear regression equation obtained between the normalized fragmentation value versus the test temperature. So from the research study, it was found that fragmentation slope is a good indicator of the physical properties of the recovered bitumen. Similarly, cohesion test is nothing but a simple ITS test in which involves compacting 100 diameter sample with 100% RAP material at different compaction temperatures with a compaction effect of 50 blows on each side of the specimen, and thereafter evaluating the air voids. The index that which we have proposed from cohesion test is the air voids. So apart from air voids, actually we have evaluated 8 other parameters. Those are ITS as well as the pre-peak slope, post-peak slope, and area under the curve. So among all the parameters which we have considered from the cohesion test, air voids were found to the better indicator for the bitumen content as well as the gradation of the wrap material. So users can use these two tests. With the help of these two tests, actually the wrap characteristics can be determining without need to extract the recovery bitumen from the wrap material. So accordingly, we have proposed the predictive equations with which actually the wrap characteristics can be estimated. So further, we have also classified the wrap materials into 5 different categories, and we have proposed the allowable limit that maximum amount of wrap that can be used from that particular category, targeting to a performance equal to the control mix properties of BC1 with VG40 bitumen. So these allowable wrap limits were proposed for the dense graded bituminous mixes, whereas for gap graded bituminous mixes like SMAs and GGRB, allowable limits can be much higher. Similarly, allowable limits can also be increased with the use of the regenerators. So in this present study, actually we would like to propose the approach for the determination of the regenerator dosage, similar to the approach by eliminating the extraction recovery of the bitumen. So the objective of the present study is to propose an approach to determine the regenerator dosage for designing recycled asphalt mixtures, which can eliminate the recovery of the bitumen from the wrap. So for this, actually, among the two tests which you have proposed, cohesion test was considered in the present study. So initially, wrap material needs to be conditioned at different temperatures for 4 hours. After conditioning for the 4 hours, the wrap material needs to be taken out from the oven and regenerator needs to be sprayed on it. So here the dosages considered for the study are 5%, 10, 15 and 20% by weight of the wrap bitumen that is present in the wrap material. Once the wrap material regenerator has been sprayed on the wrap material, so it will be taken further to compact the sample and air voids were determined. From that air voids again, the slope of air voids will be determined as explained previously. That is one part. And second part, actually, the regenerated wrap is further subjected to the extraction and recovery, and the bitumen is recovered, and the rheological properties of the bitumen were determined. Based on the rheological properties and the target grade bitumen, the allowable wrap content that can be used for that binder stiffness was evaluated. At the end, relationship between the allowable wrap bitumen content and the test index and the regenerator dosage was evaluated. Based on the findings, approach for the determination of the regenerator dosage was proposed. In the present study, actually 2 wrap sources were considered. It can be seen that both wrap sources was obtained from the same location, that is Gujarat, and both were 10 to 11 years old. And you can see that viscosity was very high. For one wrap source, it is almost 1,50,000 Pascal second, whereas for a second wrap source, it is around 76,000 Pascal second. So present study was carried out with using 2 regenerators. One regenerator is that is currently commercially available in the market. Another one is the waste vegetable oil. So for these 2 wrap sources, actually the proposed two tests, that is fragmentation test and cohesion test was carried out. And based on the indices obtained, it was categorized as the category 2 and category 3. From these 2 categories, actually, the maximum allowable wrap content that can be used without regenerator dosage was comes around to be 5% with VG30, whereas with VG10 of softer grade bitumen, it can be increased up to 20% for R1 wrap source. Similarly, for R2 wrap source with VG30, it is 15%. With VG10, it is 30%. These limits can be further increased with the use of the regenerator. So the results and discussion part will be discussed by Taumani.
Uh, Good morning, everyone. So for this analysis, both mixture level as well as binder level analysis, we have taken 3 different dosage of rejuvenator. That is 5, 10 and 15% by weight of wrap bitumen. So here, whatever we have mentioned, this is by weight of the wrap. So the air weights, which is determined from the compacted specimens, that is 100% specimens as part of the cohesion test, is shown here. From the figure, we could clearly see that with the increase in the rejuvenated dosage, there is a decrease in the air weights. This is because of the decrease in the viscosity of the material. Thereby, it increases the compactability of the material. So here we have presented the quotient test index, that is SCR whites between the normalized air whites with the conditioning temperature. So from this results, we can clearly see that the addition of the rejuvenator, irrespective of the type, has increased the slope of the normalized air whites, which indicates decrease in the viscosity with the addition of rejuvenators. So from the four figures, we could clearly see that the magnitude of S aeroid is completely dependent on the wrap source, the type of rejuvenator, and the dosage of the rejuvenator, which indicates that the index parameter, that is the quotient test index, is capable of capturing the sensitivity due to the wrap source and the rejuvenator type as well as the rejuvenated dosages. So when it comes to binder level analysis, we have taken 100% wrap bitumen, and that was rejuvenated with 5, 10, and 15% of rejuvenator, both commercial as well as the waste vegetable oil. And the rejuvenated bitumen were used to determine its complex shear viscosity at 60 degrees Celsius within the LVE limit, and the viscosity values are shown here. So from the table, we could clearly see that the addition of rejuvenator has reduced the viscosity, and it is further less when the rejuvenated dosage is increasing. And we could clearly see that there is a two different trend for R1 and R2 source as well as commercial rejuvenator and then waste vegetable oil. So based on these viscosity values, we want to determine the allowable wrap content with the help of blending charts, which is given in the MS2, and the values are mentioned here. So for this allowable bitumen content, so we have used VG30 as a base bitumen, VG30 as a virgin bitumen, and VG40 as control bitumen, and these are the values we have got. From this allowable bitumen content, we could clearly see that with increase in rejuvenator, there is increase in the allowable wrap bitumen content. So considering the similar trend which we have observed in the mixture level as well as binder level, so the correlation is established between the allowable wrap bitumen content and SAR whites, and the correlation is shown here in the figure. So here we have got a moderate correlation, that is 0.69, in spite of having a good correlation between both of them. So this is because of fact that the allowable wrap bitumen content is completely depends on the viscosity of the bitumen alone. When it comes to the SAR whites, it depends on two parameters. One is the viscosity of the wrap bitumen and the wrap bitumen content present in the wrap source. So the SAR white should be corrected based on the wrap bitumen viscosity as well as the bitumen content to achieve a better correlation. And that was carried out with the help of the equation proposed here. So here in this chart, we could clearly see that the allowable, after doing a correction depending on the base bitumen, the wrap bitumen viscosity as well as the content, there is a good correlation observed between the allowable wrap bitumen content and the corrected SAR whites. At the same time, we could observe a very good correlation between corrected SAR whites and SAR whites. So all these good correlations indicate that cohesion test index, that is SAR white, can be a very good parameter in mixture level, and that can capture the changes in wrap properties with the addition of rejuvenator, includes different type of rejuvenator as well as the rejuvenator dosages. So based on this very good correlation, so we have come up with the proposal how to determine the rejuvenated dosage depending on these indices. So in this case, we need to oven dry the wrap material at 40 degrees Celsius for 2 days and determine the wrap properties, and choose the wrap content which we need to use in the mix, and determine the total bitumen content which is required for the design gradation from the equation given in MS2. And based on the allowable wrap content, determine the allowable wrap bitumen content from the total bitumen content. So once we know the allowable wrap bitumen content from this particular chart, we can determine what is the corrected SAR whites required. For this corrected SAR white, we can determine what is the SAR white which is actually we need to get. So based on this SAR white is the one we need to achieve to get the higher amount of wrap in the particular mix. Once we know what is the SAR white need to be achieved, then we can do trial and error process on the rejuvenator, and we can come up with the suitable rejuvenator to achieve a selected allowable wrap bitumen content. So from our study, we have identified that the quotient test inject, that is SAR white, is capable of capturing the change in the rejuvenator, the wrap properties depending on the rejuvenated type as well as the rejuvenated dosage. So that can be a very good indicator to choose or to select the rejuvenator type depending on the wrap source parameters using the given correlation charts here. And by doing so, we can eliminate the use of
sophisticated equipment such as DSR and Rotavap in the field level analysis. So we are still working on this particular analysis, and we are working on like few more app systems to strengthen the relationship, whatever we have shown here. And we are as well as working on validation of the proposed methodology. Thank you.
Thank you, Mr. Thawmani and Dr. G. Gurunath, both from IIT Kharagpur, for such well-researched topic. Now, we are heading for another interesting and relevant topic. Presenter is Ms. Anusha Toshikhani. She'll be speaking on expanded clay aggregate as an integral curing agent to produce stiff mortar mixes for fixing applications, a laboratory study. She is from IIT Bombay.
Very interesting topic discussed so far. A very good morning to one and all. I am Anusha Toshikhani from IIT Bombay. So today I am going to present my topic on expanded clay aggregate as an internal curing agent for roller compacted mortar mixtures for pavement application, a laboratory study. And I'm working under the supervision of Professor Solomon Daberma. So before starting, let us understand what is this roller compacted concrete and how it is different from conventional concrete pavement. So here we can see that the roller compacted concrete is basically a zero slump concrete, which has zero slump compared to the conventional concrete, and it can be vibrated using vibratory roller as that of the asphalt concrete. So it doesn't require any tower, tie bar or double bar or any framework. And also because of this no tie bar and double bar, the cost of construction is comparatively very less than the conventional concrete. And this requires more fine content than of the conventional concrete. So here is the graph which shows the comparison of material required for the conventional and concrete pavement. So the material is similar, but cement content is comparatively required is lesser than that of the conventional concrete, and fine content required is more. So here is the graph shows the load bearing capacity of roller compacted concrete compared to the conventional concrete. From the graph, we could see that the load bearing capacity from the initial stage of RCCP is comparatively more. Now, why is the load carrying capacity is more? Because the compaction is done using the roller compacted, so the friction between the aggregate is more, and also the hydration due to the cement content is also more. So now let's understand why the curing is very essential for the concrete pavement. Now, what are the issues we are facing related to the curing? So first is that delay in opening to traffic due to the longer curing period. As we know that due to the after the construction of the concrete pavement, we have to close the concrete pavement for at least for 7 days for proper curing, and also due to which there is very inconvenience to the users too. So apart from that, inadequate curing can increase the residual stresses at the initial stage, which would lead to the plastic shrinkage cracks and drying shrinkage crack, longitudinal cracks at the initial stage. And also, it will affect the rate of hydration. As we design the pavement for M40, it may not be able to achieve the design category if it is not cured properly. So next is that premature cracking at the early age. Next is that poor workmanship. As we know that we say the curing is for 7 days, but due to poor workmanship, there is no proper curing is taking place. So because of this, there might be the raveling and scaling due to the inappropriate curing. Next is that longitudinal crack could be seen. The one of the reason for longitudinal crack is excessive drying shrinkage stresses. Now next is that alligator cracking. Next, the plastic shrinkage cracks. Now next to the transfer cracking due to the excessive drying shrinkage stresses. Now what this curing does? The curing basically minimizes the moisture loss and maintain temperature within the concrete pavements. Next is that it will give impact the properties like hardened properties, surface properties. Next is that it will lead continuous hydration so that the growth is earlier. So now, is there any solution so that we can reduce the curing period and also reduce the shrinkage cracks that is happening in the concrete pavement? Now let's see what might be the possible solution. The one of the possible solution is internal curing in concrete pavement. Now what is this internal curing? Internal curing is that basically it will retain water within the structure and release when the surrounding paste dries or when there is a relative humidity decreases. So it will create a moisture gradient that drives water into the cement paste, and it will only drives only when it is required. So it will provide uniform hydration across depth of pavement. So let's see the comparison of the conventional concrete with the conventional curing method and with the internal curing method. So in the conventional curing, since now we can see that the pavement is constructed to very low to low water cement ratio so that the strength gain is more. But this structure are very dense. So the conventional curing done may not be able to penetrate throughout the depth. So this will increase the risk of shrinkage. Also, there might be the chances of gurling and wrapping stresses that will develop in the pavement. So also, as per of the as per ILC code, also we need minimum 14 days of curing is required, or at least 170% of compression stress. So this 14 days traffic closure is required. So in the internal curing, water is distributed throughout the concrete. As we see in the conventional concrete, we were curing from upwards, but here inside it is distributed throughout the structure. And because of this uniform distribution and moisture content present, it will reduce the built up stresses in the concrete, and it will reduce the shrinkage. So this will also require lesser curing days since we are increasing the initial hydration due to the curing. So what is this internal curing and how this could be done? There are basically three most prominently used internal curing agent. One is that cellulose fiber, second is that lightweight aggregate, and third is superabsorbent polymer. In my study, I have used expanded clay aggregate, lightweight aggregate for the as an internal curing agent. So what are the potential benefit of this curing would be reduction in autogeneous shrinkage and early age cracking, which is happening in the early ages. Then it will reduce the plastic shrinkage cracks and improve the ITZ of the microstructure, and this will reduce the curling and wrapping. So now let's deeper understand what is this internal curing mechanism and how does this take place. So first is that water is lost within the concrete pavement. First is due to the hydration that is taking place. Second is that due to the evaporation. As we know, the concrete pavement area to volume ratio is high. So when it is open to the surface, the evaporation take place tremendously compared to other pavements. Next, the main goal of internal curing would be to provide sufficient internal water so that we can avoid self-desiccation and maintain saturation in the hydrating cement paste. So now let's see theoretically how much water is required for complete hydration. So basically 0.3 gram per gram of cement of chemically bond water is required and 0.19 gram of gel water. So overall we need 0.42 water cement ratio for complete hydration. Remaining water we add is just to seal to avoid the capillary pressure that is being developed. So this in the graphs we can see that from the sealing the capillary pressure is reduced. So as seen in the figure here, the mechanism. So the lightweight aggregate is usually basically like a sponge. It is like we are dipping in a water. It will hold a lot of water. So it will reduce only when stress, like when we apply stress on our hand, it will release at that time. Similar thing happen inside the concrete too. So the sponge is a lightweight aggregate. We are pre-soaking it. It hold lot of water. Now we are replacing it with the sand. So when it is in the concrete, it will just hold. It will not take place in the initial water cement ratio. It will release only when there is a usage of water due to hydration and when there is a stress created, and when they due to the initial setting, there will be a formation of vapor filled pores that will lead to sucking. So due to this pressure, due to this capillary pressure, the water will move out from higher energy to the lower energy. So the water will move out and distribute toward the concrete surrounding paste. So this is a medium. So initially the void space is a medium which will act the water movement from higher energy from the water in the lightweight aggregate to the cement paste. So there is also an ASTM code for the internal curing of the concrete. So basically they use demand versus supply formula to determine how much internal curing water to be added. Next is that I will tell you about the methodology I have adopted to determine how the internal curing in the concrete pavement. First is that I have used expanded clay aggregate as an internal curing agent of 1 to 4 mm size. So the characterization of ECA has done to determine if this can be effectively used as an internal curing agent. Next, I have replaced with different percentage like 10, 5, 10, 15 and 20%. I have replaced it with the sand. Next, I have done micromechanical analysis to see from the BSC image to analyze if the distributed water across lightweight aggregate is effective or not. Next, I have analyzed the engineering properties such as compression and flexural stress using two different curing methods. One is that water curing and one is that sealed curing. Next, morphological studies such as degree of hydration, how much hydration has been happened due to this internal curing. So the characterization of the expanded clay aggregate, the most important aspect is how much water it can hold. Next, how much water it can release, like water absorption and water desorption. So for the water absorption, I have pre-soaked my lightweight aggregate in 1 day, then I have checked what is water absorption. Similarly, I have done till day of 7 days. So I could see that till 7 days, the water absorbed could be 34.66%. So in 1 to 4 aggregate size, it was able to hold 24.66% of water. Next, desorption study. Desorption study is that the water, the whatever the lightweight aggregates that hold water, it should also be able to release at different humidities. Like in the concrete, we will be having different humidities, so it should be effectively releasing those water. So the studies we could see that the 90%, 95% relative humidity, the water was slowly releasing. It was releasing every day, like 1 day, 2 days, 3 days. We could see that it was releasing, and this test we have basically conducted using supersaturated solution and placing it in a controlled humidity chamber and checking what is the moisture loss that is taking place every day. So after understanding this study, we could say that this ECA can be effectively used as internal curing agent. Next, the mixed design approach was the ECA was soaked in the water for 24 hours. Then the gradation was done since the 1 to 4 was used. So only the sand of 1 to 4 was replaced so as to fit the gradation. Next, for the RCCP concrete, the design is basically approach is basically using through OMC MDD that we basically use for the soil. So similarly, this was done at all the different replacement like 5, 10, 15, 20% replacement of ECA. And through this, the concrete mixture design was formulated. Next is that the fresh properties was conducted. So for the different percentage, we could see that whenever we were adding higher content of ECA, the flowability was increasing. The flowability was increasing basically due to ECA is very soft and very round in structure. This was not able to create enough friction to maintain zero slump. But it is to be noted that RCCP needs stiff mix so that it can be roll compacted. So the percent of replacement, the optimization should be also based on the based on the workability of the concrete. Next is that air void content was also observed. So the observation was that workability increased due to the addition of pre-soaked, due to round shape and friction between the particle. Next, the degree of hydration. The degree of hydration was basically calculated using loss and ignition method. Then we could see that for both the water curing and seal curing, the degree of hydration was increasing compared to the controlled concrete mixture without internal curing. So this observation was that results show that degree of hydration increased for both sealed and water cured, and it increased up to 24.38% water cured when we were replacing different percentage of ECA. Also for the seal curing also, the 2.8 to 13.1% was increasing. Next is that on engineering properties like compression and flexure. This is a test result for compressive strength for both sealed and water cured. And
Miss Anusha, another 1 minute, please.
yes, right. So the observation was that we could see that there was an increase in the strength. Next, the microstructural study was conducted to see how the porosity near the lightweight aggregate, if the ITZ is becoming dense or how it is affecting. So we could see that the porosity was decreasing near our lightweight aggregate by 11.1%, whereas for control it was 20. This was that due to additional CSH product that was forming due to the hydration. So similarly, the segregation test or distribution test was conducted using image analysis. Slice was cut from top layer, middle layer, and levels to see how the distribution take place. So we could see that at the top, the aggregate have come due to the lower density, it has come up. So the key point was that this might be due to the segregation. So the optimization is required for the vibrations to check if it is uniformly distributed. Next, the conclusion is that the strength was increasing, degree of hydration was also increasing for the water cured and seal cured. So microstructural analysis, it was also confirmed for microstructural analysis. So major outcome is that concrete mixture would be less sensitive to curing if we are using internal curing, increased strength, reduced shrinkage, reduced curing period, and curling and wrapping too. So these are other research work, ongoing research work from IIT Bombay from pavement material. So there are a few more. So these are our esteemed faculties from IIT Bombay. I would like to thank all our faculties. Also IRC for giving an opportunity to showcase my work. Thank you. Thank you for your attention.
Thank you, Ms. Anusha Toshikhani, for such a lively presentation. Now I invite Mr. Thumaluru Vikas Kumar Reddy from NIT Raipur. He would be presenting on stiffness-based approach for quality control of treated granular in low volume roads using lightweight deflectometer. Mr. Reddy, please.
Good morning, everyone. I am Vikas Kumar Reddy. I am honored to welcome you all to my presentation entitled Stiffness-Based Approach for Quality Control of Treated Granular Layers in Low Volume Roads using Lightweight Deflectometer under the supervision of Dr. Sunny Deval. This coming to the outline of the study, I will first provide a brief introduction to the background, problem statement, and objectives of my study. Following that, I will explain the objective-wise main findings of and study conclusions, recommendations, and future scope of and limitations. And coming to the introduction part of firstly, coming to the area of the low volume roads, in developing countries, low volume roads play a significant role in transport infrastructure and maintenance of these low volume roads, resource intensive compared to other infrastructures. So during the design and construction of phases, low volume roads are given the lower priority, which can result in need the maintenance and rehabilitation during the payment service life. Let's shift to our focus to primary load bearing component of the low volume roads, that is the granular layers play a crucial role distributing traffic loads and provide essential structure support to the pavement. Granular layers in low volume roads initially categorized into two types: untreated and treated granular layers. Untreated granular layers consist of natural aggregates providing stability without chemical stabilization, and on other hand, treated granular layers receive a certain doses of chemical stabilization through additives. In that, lightly treated granular layers represent one such classification. This is a small amount of chemical stabilization, that is less than 5%. Uh, Quality control helps to improve the performance of pavements in various ways, such as resisting moisture damage and improving durability. Currently, the industry employs a range of methods for quality control, including measuring dry density, moisture content, and gradation. These measurements are derived from both laboratory and non-destructive tests. So quality assurance of the lightly treated granular layers should also be efficient to avoid delaying construction progress. Therefore, an efficient non-destructive technique is necessary to measure the resilient modulus of the compacted lightly treated granular layers. Coming to the problem statement, the compaction is a significant part of the pavement construction process. If performed improperly, deformation of the layer material could occur, stiffness of the pavement decrease, and result in structure failure and maintenance costs. Currently, the density-based compaction control is used quality control during the compaction process. However, a few specific challenges have been reported in compaction control based on density. Density-based method may not reflect the material's behavior under loading conditions, especially lightly treated granular layers, and unable to capture the heterogeneity of the lightly treated materials in the site, especially by sand replacement method. So therefore, there need large number of test validations to capture the heterogeneity in the material. Therefore, there is a need to look alternative approach for ensuring strength parameters rather than the density based assessment. Coming to the curing period, it is also crucial to ensure that the treated granular layers have reached the required strength and stiffness before the next layer is laid. The curing process of treated granular layers can take several days or weeks depending on the types and doses of the stabilizer. So very often, coring cannot be possible for treated granular layers, especially for bioenzyme treated materials. So there is need to assess the effectiveness of LW testing on various curing periods and determine the curing period to ensure that treated granular layers has reached the required stiffness. So they are my objectives coming. Our research aims to comprehensively investigate treated granular layers uh, focusing stiffness values and layer responses. To achieve this, we have outlined specific objective covering a range of aspects in the study of light heated granular layers. This slide provides a typical layer compositions, and in the subbase layer, the soil aggregate mix from borrow-pit soils or pavement sections used for subbase layer. Treatment with predetermined doses of either cement or bioenzymes have been used. And I have considered the during construction tech sections for for the study. In this, soil aggregate samples from borrow pits or in-service pavement sections in laboratory have been investigated. These are the photographs of some raw materials. Coming to the mechanism of bioenzyme, the typical process adopted in this study for treating soil aggregate with bioenzyme is illustrated in this figure. Enzyme stabilizers are attached to the large organic molecules, which in turn agglomerate the clay particles. Then clay minerals have a net negative charge, which causes large organic molecules to be attracted to them. The attraction neutralizes the negative charge of the clay minerals, reducing the water affinity. So this mechanism decreases the pore swelling, moisture content, and shrinkage while increasing the soil stability. So these are the properties of bioenzyme. These are the experiments performed during my study. Coming to the LW lightweight deflectometer, principle of lightweight deflectometer, an impulse load is imparted by a drop weight on the circular plate and into the soil, and response of ground is measured by geophones. These are the specifications of LWD test. So these are the how the LWD test was performed on selected test locations with lateral geophones. Coming to the laboratory investigations, the LWD test on test pits. Here I have the dimensions of the container is 750 mm and 450 mm diameter to eliminate the boundary conditions. A two-layer system comprised of subgrade layer and treated subbase layer has considered. Here, the LFD test was performed on the top of the subbase layer at day 1 for cement treated and day 7 for bioenzyme treated to assess the compaction efficiency. On top of the subbase layer at day 7 and day 14 for to evaluate the curing mechanism. The purpose of the conducting LFD test on test pits is to assess the compaction efficiency and to evaluate the curing mechanism. Coming to the first objective, the material. These are the material descriptions. And the methodology for uh, for evaluating the curing mechanism. Here I have performed the laboratory test and field test. Here I have performed before going to the field. I have performed the laboratory test on Proctor. Sorry, performed on subbase layers in test pits. Then find out the target stiffness values. So based on the target stiffness values and density values, and I have performed the LW test on test locations and note deflections and to calculate the stiffness modulus, and perform the sand replacement test to find out the density. At each after each vibratory compaction pass, I have applied the LWD test and the sand replacement. Whenever the field stiffness values is less than the target stiffness values, then there is no need to apply the next uh, pass. These are the procedure to how to develop the stiffness based compaction mechanism. These are the target stiffness values test results for cement treated test sections and bioenzyme treated test sections. These are the test results observed in the field after sixth pass, seventh pass, and eighth and ninth passes for test section 6 and 7 and 11, 12 sections means cement treated and bioenzyme treated test sections. Here it is observed that at test section 6, it in all test stations means at each chainages, after seventh, some locations at the seventh pass, the target stiffness values are achieved, and some locations at the ninth pass, target stiffness values are achieved. But during the test section 7, it is observed that at chain age 1.6, the compaction control is not achieved even at the ninth pass during based on the target stiffness values. But at the same location, based on the target density, it is achieved at ninth pass only. The same scenario is observed in test section 11 and 12 also. So it is observed that the average passes required based on target stiffness values are less as compared to the target number of passes required to achieve the target density. So these are the statistical limitations I have considered, that is average plus 1.5 sigma plus average minus 1.5 sigma. Here it is observed that only the two test stations having the difference in deflections out of the boundary sections, and the standard deviations also observed very less. It means that the most test stations, the difference in deflection values are within the boundary levels. So, so therefore, the average of these difference in deflection value considered as a permissible differences in deflections of two successive compaction passes. The same scenario has observed in test section 7 and 11 and 12 also. So they are the conclusions for objective 1. The target stiffness values and variations in compaction efficiency. So it is suggested that the permissible difference value is 0.014 for cement heated sections and 0.016 for bi-engineered heated sections, providing the flexible based on actual section behaviors. Coming to the objective 2, this is the material description and the methodology. These are the target stiffness values I have observed in cement for cement heated sections and bi-engineered heated sections. Here D0, D30, D60 indicates that the central deflections and the lateral deflections. Here it is observed that the combined inner wheel path, center and outer wheel path values of D0 values from day 1 to day 7 has been decreased, and also it is observed that in D30 also the D30 values also decrease from day 1 to day 14. The same scenario has been observed in D11, test section 11 and 12 also. So these are the stiffness values.
Mr. Vikas,
Here also, sorry.
please, another 1 minute, please.
Yes, sir. So summary of the percentage gain in back calculated layer moduli values of subbase and subgrade layer modulus. Here the stiffness values are there is no variation from 1 to 7 in in subgrade, but there is a variation, drastic variation is observed in subbase layers because of treated layers. So conclusions here, D0 deflections represent treated subbase layers, and D60 deflections remain relatively constant again across different test sections. So D30 values decrease with curing more gradually than D0, indicating depends on both layers. So final conclusions. Alternative compaction control approach, suggesting an alternative approach for in situ compaction control of treated granular layers using LWD. The number of passes and permeable difference in deflection to successive compaction passes are the significant parameters of stiffness-based compaction control. Monitoring of curing process, variations in deflections by using lateral geophones are found to be key indicators. The rate of gaining of subbase backlash layer model values of cement heated and depicted more from day 1 to day 7 as compared to bioengine treated layers. This is the future scope and some of the limitations of my study and the references. There are some photographs. Thank you. I would like to thank you, IRC and NIT Raipur.
Thank you, Mr. Vikas Reddy, for such nice presentation. Like, open the floor for the intervention. Okay. Thanks, delegate, for such patient listening. So now definitely you all have must have lot of queries. after listening to these papers, these presentations. So now floor is open for intervention. You are welcome to raise queries. And I'll request we go in the same sequence as the presenters have given their presentation. So starting with the first presentation, that was by Mr. Soumyaroop Vishwas. So the topic was comparative assessment of different maintenance strategies in bituminous and concrete pavement using life cycle cost analysis. So any delegate having query regarding this can please ask this query. Presenter would be here to reply. First one. The first query which we received here is from Mr. Vikas Thakkar. So he can speak. Yeah, if he is here, he can stand and speak out directly to the. Yeah. The mic, please.
I had a query for the first speaker. He talked about the deterioration models in the LCCA module. So, are they correlating to the deterioration models that are considered in IRC 37 and 58? Or are you talking about some different deterioration model based on your research?
No, actually, these are different models. These are not based on IRC 37 or 58 models. These are completely new models. So based on 2015, 2016, 17 data, IRI time series data, RUDDEP time series data. So we could also collect some section details and traffic data. So based on that, we have developed the models. But these are completely independent of those, actually.
Okay. Yeah. Thank you. Any more queries on the first topic? Okay. Uh, thank you, Mr. Somisru. Okay. Now we go to the second topic. That was by Mr. Suraj Gupta. Topic was analysis and visual preference in hazard perception, gender-based and driving experience effects. So we have received one query regarding this from Mr. Amit Sharma. Mr. Amit Sharma is here. Mr. Amit Sharma from RCD Bihar. No, sorry, not Bihar. Mr. Amit Sharma is here. Okay. Can you make out the query? If you can make out, you can reply. Sorry. Query is with you. Yeah. If you just read.
Actually, this is not a exact query, but this is a suggestion regarding the head-on collision. Most of the driver mostly observe the accident mainly head-on collision. So they just suggest me to just include that type of hazard also in my study.
Any other queries on the topic?
Any delegate having query regarding topic number 2? Okay, thank you. Okay, thank you.
Sir.
Now coming to presentation number 3, that was methodological framework for identifying passenger subjective comfort, focusing on lateral clearance by Mr. Mohan Kumar. So any query regarding that? One query which we have received from Imtiaz Ahmed. Mr. Imtiaz Ahmed from RCD Bihar, is he here?
Mic ले दीजिए.
Yeah.
Mic, please.
The query is like, what should be the minimum lateral clearance from for two-lane divided highway from a rigid divider? So like it is out of our scope. We haven't conducted any study right now on this two-lane divided highway. We have conducted it on two-lane undivided highway. So we do not have any particular answer for that. However, it can be considered, and studies has to be conducted rigorously to identify that value. Yeah. Any other queries?
Question. What to?
Sorry, I have given to this.
You can tell him.
It's not pertaining to you. Okay,
Number
just
two.
go.
Number two queries.
Okay, that probably presenter 4 would be covering. Okay. Okay.
Okay.
Okay. Thank you, Mr. Mohan Kumar. Now, okay. Coming to next presentation, that is that was by, okay. Uh, next presentation was by Mr. Rahul Kumar Chandra, an automatic curve radii extraction algorithm using naturalistic driving data. So one query related to this is again Imtiaz Ahmed from RCD Bihar. So
Actually, there is no query here. Only the present name is my name is mentioned.
this query is from Mr.
Yeah,
Imtiaz Ahmed.
yeah. Imtiaz Ahmed.
Hello. My question is that the major cause of accident is due to collision with the rigid divider, leading to accident causing the death. So what should be your recommendation, your reply? How to minimize the accident with collision with the divider?
Sorry, sir. I couldn't
Can
hear.
you hear? Can you hear?
No, I can't hear.
You
So
pass on
this
the mic.
the collision with divider is major cause of road accident leading to death. So that is not the scope of the study. So the study is to extract the curve geometry or the geometry horizontal alignments geometry details. So okay, the collision in my case, so we are trying to develop safety countermeasures to reduce these crashes along the highways presently. So for that we are trying to get the geometry. So that is the scope of the study. So uh, it is not relevant to us.
Okay. Go ahead with the next.
Okay.
Thank you.
Thank you, Mr. Rahul. Okay. Now the next presentation were Dr. Gurunath and Mr. Thawamani. So they had a presentation on a new approach for determining rejuvenated doses for designing bituminous mixes with reclaimed asphalt pavement material. So any query regarding this? Any delegate is having would like to raise some question? Okay. Okay. Now moving to next presentation. That was by Miss Anusha Toshikhani. Expanded clay aggregate as an internal curing agent to produce stiff mortar mixes for paving applications, a laboratory research. So,
Queries?
any delegate having any query regarding this? M-
Like
Mr. Vikas Kumar Chaturvedi has given one query. Mr. Vikas Chaturvedi, is he here? Okay.
you can just pass on.
Okay. Now we can just see.
Regenerated suggestion. No, you can always say it's a suggestion. The scope of work paper is this, and this is a suggestion. We'll take up in the part of your result and discussion of our I think this is also pertaining to you. This is really great.
So I received a query regarding Brijesh Kumar. So it is there mentioned that good idea to conduct research. Task required to assure quality tangent material is explained, and they are said that research should be also be implemented practically. So I would like to thank, and we will say that in future we will be applying in practical application too. Thank you.
Thank you. Now coming to the another presentation of the day. That was a SNFs-based approach for quality control of treated granular layer in low volume roads using lightweight deflectometer. Presenter was Mr. Vikas Kumar Reddy. So, any delegate having query regarding this?
What do you do about the regenerator? We have one query. We'll address it. So he'll go.
Dr. Gurunath would be addressing one more query.
Yeah, there was three queries from Anush Sri. So in the proposed methodology for determining the optimum regenerator dosage, it is mentioned that the virgin binder quantity is determined by the method proposed by MS2. So this is not the virgin binder, this is the total bitumen quantity. So you can refer MS2. Actually, there is a equation which has been proposed based on the design gradation. You can determine the total binder content, not the virgin binder content. That is the first thing. Second thing, yeah. So second one is similar to the first one. So third question is I couldn't grasp your complete methodology. Can you give a more precise explanation on your methodology? It will be helpful for my PhD thesis. Fine. So the final approach which we have proposed is initially we are supposed to take the wrap material and we need to dry it for 2 days in the oven in order to remove the moisture content. Once that is removed, then you can determine the wrap characteristics using the equations which we have proposed from the two indicative tests, that is the fragmentation as well as the cohesion test. Once you know the characteristics, then you need to decide what is the allowable wrap content that which you want to use. So you know already the wrap characteristics like gradation, you know the bitumen content, you know the bitumen type. Either it might be a penetration softening point, whatever you are interested. Once you know these characteristics, you know the allowable wrap bitumen content. You also decided the wrap percentage which you want to use for the design of hot recycled asphalt mixtures. So you are having the wrap gradation and you know your target gradation. So based on the job mix formula, you can arrive at the design gradation. Once you know the design gradation, using the equation which has been proposed in the MS2, you will be arriving at the total bitumen content. You know the wrap bitumen content. Now you are having the total bitumen content. If you can divide the wrap bitumen by the total bitumen, you will get the allowable wrap bitumen content. That is the wrap binder percentage, I can say. That is what has been mentioned in the blending chart also. Once you know the wrap bitumen content, then you can use the chart which I have proposed. From the allowable wrap bitumen content, you can determine the corresponding corrected S air voids. Using the corrected S air voids, you can determine the corresponding S air voids. Now you are supposed to determine the regenerator dosage that is required to arrive at that particular S air voids, which you have determined from the chart which I have shown in the presentation. That's it. Once you know the allowable wrap content, you are having the wrap bitumen content, you know the regenerator dosage. Now just you have to do the uh, prepare the bituminous mixes at different trial binder contents. Just by changing the fresh bitumen dosage, you need to prepare the Marshall mixes, then you can determine the volumetrics and correspondingly you can arrive at the optimum binder content. Then you can do the performance, then rest is, anything else? Thanks for your queries.
Okay. Thank you. Okay. I would like to thank every one of you, the presentations who have given the very well researched presentations covering very relevant topics, especially leading for the road sector. And my particular focus would be on the road safety. And one of the presenter has already mentioned the statistics that we are losing Every year, we are losing, which is the MORTS data, we are losing 1.7 lakh precious lives every year. There's a huge data, and almost 4 to 5 times of this number, that is roughly 8 to 10 lakh, are serious injuries. And when we talk about the injuries, that is costing almost to 3% of GDPs. All road accidents which are taking place in India, that is amounting to 3% of the GDP cost. There's a huge figure, and MORTH is laying lot of emphasis on making roads secure, implementing road safety measures. A lot of policies have been made in this regard, and a special drive has been taken up. But still, road accidents as on today are maximum in this part of the world. As statistics are there, we are not even 10% of total global vehicle, the figures, total number of vehicles in world, whereas share in accident is almost 40 to 50%. That is a huge number, and the government is also trying very hard. Ministry of Road Service also taken up measures to reduce these road accidents. One life cost is just a number for all of us, or for that family. Loss of one life is complete loss of world. That we must realize. And in this forum, we have seen presentations dealing with this road safety aspects as well as the other presentations have covered very nicely various topics, like especially the life cycle cost when they is talking about. So, Dr. Gurunath has also covered regarding the regenerator doses for bituminous and mixes. So, as we all know, natural resources are very scarce, especially one which is used in the roads. Huge amount of quantity of aggregate are used. So, idea is to make minimum use of natural resources so that we can preserve those resources, and as well as give a good riding quality, good roads for the users. So now I hand it over to our chairman, who would like to add some more on this presentations. Thank you.
Good afternoon. We had array of PhD scholars presentations, a nice gesture to look at tomorrow. And in fact, they deserve round of applause from this huge audience over here. I have some suggestion being a research scholar myself. I go sequence wise as far as this is just suggestion might appear into your research and discussion if you think so. Coming to the first presentation, which was life cycle cost, a comparison drawn between bituminous concrete roads. I think you can just add there what happens to the life cycle cost when actually you work on greenfield and brownfield independent project where there is no hindrance of traffic. But as long as when you work in an existing alignment, things are different. I think that can be just thought of. Coming to hazard prospection, there was a beautiful presentation more on the factor, which is the human factor. And I think then can be more elaborate things on environmental hazard along with the dynamic and static hazards as classified by the presenter. Coming to the third presentation, which was as regards to lateral clearances, I think recommendation of IRC are simply clear. What are the clearances you need to adhered to. So some cross reference if it is drawn with reference to IRC codal provisions and your study. I think that can be a part of your discussion. Coming to fourth, that was just designing a horizontal curve uh, was really eye opener, and I think something can be initiated on design of vertical curves too. So may not be the same scholar. It can be passed on to your institution to have opening some avenues for studies on vertical curve too. Uh, Fifth was on rejuvenated dosages. Other fantastic concept. I think the presenter has studied on the two options. One was vegetable oil, I suppose, and the commercial rejuvenator. I think a cross reference can be drawn for the use of other rejuvenators like the plastic, heated plastic. Just a part of your discussion, I think that will give an idea of what is the present trend and what you intend to do to improve upon it. The sixth one was expanded clay aggregate. We see most of the rigid pavement fail due to shrinkage cracks, inadequate quarrying, and that was another very good presentation. Use of clay aggregate as an alternative for without compromising the flexural strength of the pavement. There also the options what she has worked out was around three options, uh, and that was really good. Coming to the last, use of lightweight deflectometer instead of cumbersome falling deflectometer for graded low volume traffic roads. I think there also you need to just have a comparison with respect to uh, the traditional IRC provisions of falling deflectometers and draw some references just to see where it stands as far as your innovation is concerned. So overall, it was a great session. Highly privileged to be chairing this. Uh, I should thank my co-chair for just assisting me in this and all research scholars for giving wonderful presentations and also the audience what I see. Normally I don't see such audience. So thank you everybody for that. And we wind up this technical session. मैडम को बोल दें
थैंक यू सो मच सर। और अब समय है सर्टिफिकेट प्रशस्ति पत्र वितरण का। सर्टिफिकेट इशू किए जाएंगे, इसके लिए मैं आग्रह करूंगी चेयरमैन सर से,
हम आगे चले यहाँ चले ये लेके
श्री
चलेंगे तो
उत्तम
better
पारशेखर जी से, और साथ ही साथ को चेयरमैन कर्नल प्रदीप गेरोला सर से कि हमारे मंचासीन जो मेहमान हैं उनको वो सर्टिफिकेट इश्यू करेंगे। सबसे पहले मैं चेयरमैन सर से आग्रह कर रही हूँ मिस्टर सौम्यरूप विश्वास और मिस्टर सिद्धनाथ पांडा जी के लिए। आप दोनों सर से प्रशस्ति पत्र लेंगे। मिस्टर सौम्यरूप विश्वास, मिस्टर सौम्यरूप विश्वास, चेयरमैन सर इन्हें प्रशस्ति पत्र देकर सम्मानित कर रहे हैं और इस सेशन को यादगार बनाने के लिए जोरदार तालियों का आग्रह आपसे एक बार फिर है। इसके अलावा मेरी रिक्वेस्ट है मिस्टर सूरज गुप्ता जी से, जिनको चेयरमैन सर के द्वारा प्रशस्ति पत्र प्रस्तुत किया जाएगा। मिस्टर सूरज गुप्ता। मेरा आग्रह इसके बाद मिस्टर मोहन कुमार सौम्य व रूपा जी से है कि वो भी सर से प्रशस्ति पत्र प्राप्त करें। मिस्टर मोहन कुमार सौम्य व रूपा। मेरा आग्रह इसके बाद मिस्टर के राहुल चंद्रा जी से है कि वो भी पहुंचे सर के नजदीक और प्रशस्ति प्रमाण पत्र प्राप्त करें। मिस्टर के राहुल चंद्रा। मेरा आग्रह इसके बाद है मिस्टर हवामानी जी से कि वो भी पहुंचे और प्रशस्ति प्रमाण पत्र हासिल करें। और मिस्टर हवामानी और डॉक्टर जी गुरुनाथन। इसके बाद डॉक्टर जी गुरुनाथा से मेरा आग्रह है कि वो पहुंचे। मिस अनुषा तोशिखानी जी से भी मेरी रिक्वेस्ट है कि वो अपना प्रशस्ति प्रमाण पत्र हासिल करें चेयरमैन और को चेयरमैन सर से। मिस अनुषा तोशिखानी। इसके बाद मेरी रिक्वेस्ट रहेगी मिस्टर तुमलारू विकास कुमार रेड्डी जी से कि वे अपना प्रशस्ति प्रमाण पत्र हासिल करें। तो आज के दिन की याद, आज के दिन सेशन में जो कुछ हुआ, जो समझा, जो क्वेरीज आई, ये सब आपको इस प्रशस्ति पत्र के माध्यम से सदा यादगार रहेगा। और बहुत सारे बधाई शुभकामनाओं के साथ अब मैं रिक्वेस्ट करूंगी मिस्टर बीएस बघेल जी और जी आर राउटे जी से कि वो मंच पर आए और हमारे चेयरमैन सर और को चेयरमैन सर को स्मृति चिन्ह भेंट करें और इस सेशन के लिए धन्यवाद दें। मिस्टर बीएस बघेल और जी आर राउटे सर। तो पहले पुष्पगुच्छ बुके के साथ स्वागत और फिर स्मृति चिन्ह। और साथ ही साथ मेरा आग्रह अब चेयरमैन और को चेयरमैन सर से कि वो यदि आसन ग्रहण कर सकते हैं तो, या क्योंकि अभी जो हमारे मेहमान मंचासीन हैं बीएस बघेल सर और जे आर राउटे सर, स्मृति चिन्ह इन्हें भी देना है जो मंचासीन हमारे अतिथि हैं। ओके सर। हाँ जी, हाँ जी 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 सर, हाँ जी। मैं सौम्यरूप विश्वास जी जिनको सम्मानित करें बीएस बघेल साहब और साथ ही साथ जी आर राउटे साहब। स्मृति चिन्ह छत्तीसगढ़ी संस्कृति, लोक कला, परंपरा से जुड़ा ये स्मृति चिन्ह जो भेंट किया जा रहा है और आज के इस दिन को, इस वक्त को यादगार बनाया जा रहा है। मिस्टर सौम्यरूप विश्वास। मिस्टर सूरज गुप्ता को सम्मानित कर रहे हैं स्मृति चिन्ह और बुके के साथ।
सेंटर में आ जाइए।
इसके बाद मिस्टर मोहन कुमार सोमा वारापू। Mr. K. Rahul Chandra. Mr. K. Rahul Chandra, मंचासीन इस वक्त। उसके बाद मेरा आग्रह है मिस्टर खाबा मानी जी से और डॉक्टर जी गुरुनाथ जी से कि वे स्मृति चिन्ह और पुष्पगुच्छ स्वीकार करें। इसके बाद मिस अनुषा तोचिखानी जी। मिस अनुषा तोशिखानी और मिस्टर तुमलारू विकास कुमार रेड्डी।
थैंक यू
सर एक और है सर, एक और है। डॉक्टर जी गुरुनाथ, हाँ डॉक्टर जी गुरुनाथ।
कुछ और है
थैंक यू, थैंक यू सो मच चेयरमैन सर, को चेयरमैन सर। यू वांट टू सम प्लीज।
लंच कहाँ पे सर्व हो रहा है कभी लंच का जाएंगे थोड़ा बोल दीजिए ऑडियंस को वो अच्छा लगेगा लंच के लिए अभी तो हो गया can break away for the lunch next हाँ तो सेशन अभी तो खत्म हो रहा है वो मैंने attendance sheet is there attendance sheet सुन
तो पहला सेशन इसी के साथ समाप्त हो रहा है और साथ ही साथ वक्त हो रहा है लंच का, ब्रेक का। बहुत धन्यवाद, बहुत शुक्रिया आप सभी का। और उसके बाद हम फिर मिलेंगे। शुक्रिया।
नहीं अपना तो ये ये भैया बक्सा दे देना बक्सा दे देना ऐसा है या नहीं थोड़ा सा थोड़ा सी थैंक यू सर थैंक यू वेरी मच ये आए हैं एक बार सब आए हैं हाँ हाँ तो बैठे हैं
बंद क्यों? ये चालू करवाइए ना। हाँ। हेलो। तो ये फर्स्ट सेशन के लिए अनाउंसमेंट था और अब वक्त है सेकंड सेशन का, जिसका इंतजार हम सभी को है। और ये टेक्निकल सेशन 4 है, जिसके लिए अब मैं इनवाइट करना चाहूंगी हमारे मेहमानों को मंच पर। इस सेशन के लिए, टेक्निकल सेशन के लिए मैं इनवाइट करना चाहूंगी श्री DR मेघवाल जी को, सेक्रेटरी राजस्थान PWD। ही इज ऑल्सो एन एक्टिव मेंबर ऑफ IRC। जोरदार तालियों के साथ स्वागत करेंगे सर। सभी लोग अपने स्थान पर बैठ जाएंगे। इसके अलावा मैं बुलाना चाहूंगी को चेयरमैन ऑफ द सेशन इज श्री PJ मिश्रा जी को, चीफ इंजीनियर R&B डिपार्टमेंट, गवर्नमेंट ऑफ गुजरात। श्री PJ मिश्रा जी।
अनाउंस कर दो सर, बुला लो नहीं। आप अनाउंस कर रहे हो या नहीं? Hello. Requested delegates are requested to be seated. I think lunch will take another hour or so. And meanwhile, we'll try to finish this program, this session as fast as possible. So it's requested, those who are interested, please be seated.
सभी प्लीज अपना स्थान ग्रहण करें, जैसे कि सर बार बार रिक्वेस्ट कर रहे हैं। 1:30 बजे लंच होगा और इसके पहले इस सेशन की शुरुआत करने जा रहे हैं विधिवत रूप से। मैं बुलाना चाहूंगी श्री GR रोटे जी को, चीफ इंजीनियर PWD छत्तीसगढ़, मंच पर आए। BS बघेल जी से मेरी रिक्वेस्ट रहेगी मंच पर आए और हमारे चेयरमैन और को चेयरमैन सर का स्वागत करना है पुष्पगुच्छ से, और विधिवत रूप से इस सेशन की शुरुआत होने जा रही है।
ये देखो ये देखो देखो सर एक बार देखो एक बार। हाँ, कौन कौन से यही आपने बोली थी सर? उसमें क्या है फोल्डर का नाम? ये PPT TS4 है ना, वन बाय वन करके।
और इसी क्रम में आगे बढ़ते हुए मैं बुलाना चाहूंगी मंच पर मिस्टर नीलांजन सरकार जी को, चीफ टेक्निकल ऑफिसर टिकटार एंड शेल इंडिया प्राइवेट लिमिटेड मुंबई। मिस्टर नीलांजन सरकार। इसके अलावा मैं बुलाना चाहूंगी मिस्टर डेविड फॉक्स को, एशियन कॉन्टैक्ट लिमिटेड। प्लीज वेलकम सर, मंच पर आपका स्वागत है। मेरी रिक्वेस्ट है इसके बाद मंथन चौहान जी से, असिस्टेंट जनरल मैनेजर मैं एक बार फिर से आग्रह करूंगी जो गेट के नजदीक हैं हमारे सहयोगी, हमारे साथी, वो प्लीज बैठ जाएं। ये कंटिन्यू सेशन चल रहा है और इसके बाद फिर 1:30 बजे लंच होगा। 1:30 बजे से जल्दी से इस सेशन को हम करेंगे, इसलिए आप सभी लोग अपने अपने स्थान को ग्रहण कर लें। एक बार फिर से रिक्वेस्ट करते हुए मंथन चौहान जी। इसके अलावा मेरी रिक्वेस्ट है मिस्टर ऋषभ गर्ग जी से, इंटरनेशनल बिजनेस डेवलपमेंट गुड लक इंडिया लिमिटेड, मिस्टर ऋषभ गर्ग। मेरा आग्रह इसके बाद मिस्टर प्रतीक सेन जी से, मिस्टर प्रतीक सेन, जोनल मैनेजर ईस्ट सेल्स डेवलपमेंट, जिंदल स्टेनलेस स्टील, न्यू दिल्ली। इसके बाद डॉक्टर शुभम कालोरी जी को मैं बुलाना चाहूंगी मंच पर। शुभम कालोरी जी, टेक्निकल मैनेजर MSZX इंडस्ट्रीज प्राइवेट लिमिटेड। और आप सभी का स्वागत है। एक बार जोरदार तालियां अब होनी चाहिए। एक एक दो दो लोग बजा रहे थे, हम सुन रहे थे, हमने सोचा एक साथ बजवा देंगे और इसको उसी ऊर्जा के साथ अब शुरू करेंगे इस सेशन को भी। और मेरी रिक्वेस्ट रहेगी कि चेयरमैन सर और को चेयरमैन सर अब संभाल लें।
Thank you. I with co-chairman welcome to all presenter, Mr. Nilanjan Sarkar, who will present purpose built bituminous payment assets. Mr. David, who will present unleashing multi-channel GPR. Mr. Manthan Chauhan, erosion control using geosynthetic solution. Mr. Rishabh Garg, who will present the use of certified safety barrier on roadside, and Mr. Pratik Sen, building sustainable infrastructure with stainless steel, and Mr. Subham Kalore, technology for durable payment. Without any formality, we have already late half an hour. I request Mr. Nilanjan Sarkar to present the purpose built bituminous payment asset. And now, floor is yours.
Mr. Chairman, sir, Mr. Co-Chairman, sir, dignitaries of on the dais, ladies and gentlemen, it's really a privilege to present in front of you, and I'll make my presentation as crisp and short. So, following the well-known 80-20 principle, this presentation is not so much about what we do as a company, as much as it is about an invitation, a humble request to collaborate with the entire industry. To set the context, I'm just sharing as a company, we are premier suppliers of innovative bituminous materials and underlined by a lot of technology support. And at the same time, bitumen or bituminous products, they have to be have integrated logistics because that's something we do. And you can see our areas and focus. And most importantly, we are here to send out a message of collaboration with the entire fraternity here. If I set the context further, okay, let's look at how the future is evolving. Now, these are some big numbers, okay? Whether it's the population, number of cars, rising energy demands. A very unique thing here is about 70-75% of the contribution to these figures will come from urban agglomerations or big cities. What that means is both the intercity network as well as the intracity road network has to be not only very durable, long lasting, but also very safe. Going forward, for any asset, whether it's a pavement or any assets, these are the three pillars. And today we'll be touching briefly on a bit of materials and around a bit of maintenance. Some of these focus areas for India, like we know as highway engineers, that India is not only facing a lot of traffic related stresses, but also a lot of environmental stresses. And some of the outcomes which I have shared here, these outcomes are not unique. There are many more. I'm just sharing it for the purpose of discussion. Now, given this really rapid economic growth that we are seeing, we need a resilient road network. And for that, obviously, we need long lasting pavements, which will demand some maintenance. But that maintenance window has to be drastically shortened. At the same time, we have taken goals for environmental impact, so that has to be as low as possible. Some of the areas where we are working on, and typically this is a 60-minute lecture, so I have condensed it into 7 to 8 minutes. So I'll be speaking on these few elements, and Mr. Chairman, well within the time. So if you look at the first technological lever we have, you think of asphalt pavement construction or bituminous pavement construction. It's like a loop. We select the materials, then we make the pavement, then we use the pavement, and then we reach the end of life. So at each stage, you look at India. India is a very big country. So when you look at actually making the pavement, are we able to use local materials, marginal materials, or do we really need to transport materials all across the country? Similarly, when we are making the pavement, can we look at low carbon efficient technologies to make the pavement? At the time of maintenance, how do we compress the timeline as well as the energy usage? Similarly, when we reach the end of life of the pavement, we need to be very vigilant. Have we used some materials which are kind of not fit for reuse or has no value in reuse? So these are some of the questions you can ask yourself when you are in any of the four areas of the loop. I'm sure all the audience here is in either all the four or in one of the four or two of the four or three of the four. Now you look at long lasting assets, okay? We obviously know they should be built with local materials, marginal materials. They should have very low maintenance costs. Now, for that, we need to shift from building a general pavement to building a very fit for purpose asset. So if an asset is going to take a traffic of 100 MSA, 150 MSA, these are very complex assets. We cannot broad brush them. We have to be very, very, very specific. And in terms of what materials we use, then when we use those materials, make a nice design. I was just talking with Dr. Akshay. You make a nice design, but then the construction procedures also have to be commensurate. We cannot just use innovative materials. We have to complement them with our ways of working, and that can be done through a lot of performance characterization. One of the very, very attractive ways of doing that is to use polymer modified bitumen. Now, not general specification compliant, but very specific engineered PMB. Now, when we look at engineered PMB for heavy duty applications, there are a lot of questions come into your mind. What is the polymer architecture? What is the grade? Now, we have 15 government refineries in India giving us bitumen. Will that polymer or will the set of polymers be able to produce those premium PMBs with all the bitumens which we are getting? Similarly, these engineered PMBs, will they be able to use our common technologies of road making, or is there a departure required? Like you look at that graph, A to D, it is very easy for a PMB to move from a very homogeneous structure to a very inhomogeneous structure in a matter of dosage which goes beyond decimal point, not even whole numbers. So when you make such engineered material, they have to retain their properties not only in the laboratory, but also in the manufacturing side, in the storage, in the transportation, in the application, and most importantly, in the usage. Similarly, another area where we can collaborate. You look at this graph, more than 60% of bitumen oxidation or aging happens even before the pavement is open to traffic. This is quite eye-opening. And if we are able to reduce this rate of aging or oxidation, we can obviously get a very durable, high fatigue life. And one of the ways is through use of low temp technologies, low temperature. You can not only use these technologies for producing mixes at low temperature and using less fuel and saving money, but from one hot mix plant, you can transport it very far away. This is especially useful for areas where there is constraint in setting up multiple hot mix plants. Similarly, like in the northern parts of India, we have intensive winter. Now you look at this intensive winter, it can open up the paving window, and within a day, it can still open up the paving window. And there are some specification suggestions given, and there are a lot of researchers here, they can contribute much more. We've built a lot of assets, and some of these assets, concrete or bituminous, will be overlaid. And one of the issues with cracked pavements is reflection cracking. we've developed a composite pavement technology, which not only acts as a stress absorbing membrane interlayer, but at the same time it is 100% recyclable. And I invite you to collaborate with us in this. This is just a pictorial. Just lastly, I spoke about some technological levers. Now some operational levers. We transport so much bitumen, aggregate, mix. Some of the things we are doing, we are trying to move towards LNG, which is a much cleaner fuel than what we are using. Similarly, some of our bitumen and especially PMB trucks, which I request all the contracting fraternity and to collaborate with us, we are now able to supply you PMB, which retains heat to a much higher degree, where your point of discharge, the reheating is avoided. And you know, the more cycles of heating you give to a PMB, the more the migration of properties happen. So lower energy consumption even at point of discharge. And lastly, why to collaborate with us? You know, we are the pioneer of PMB, 50 years plus in PMB. Our project, our materials have been used in any conceivable asphalt application in the world, and we have a combined experience of more than 160 years. Just for food for thought, we need to move away from looking at a road as something which connects point A to point B. Can we use it to light our streets? Can we use it like 75% of the future population will reside in cities and urban agglomerations? What about the urban heat island effect? Can a pavement contribute to that? And similarly, what kind of data can we get? Now everybody's talking about smart technologies. So that I conclude with that. Anybody interested to discuss further, this is where you can find me and my team. And thank you, Mr. Chairman, and thank you, audience.
Now I request Mr. Manthan Chauhan to present the topic erosion control using geosynthetic solution. Now, floor is yours. Please conclude in 10 minutes.
Yes. Good afternoon, all. So I'm here to represent McAfee Environmental Solutions Private Limited. Starting with our introduction, we are basically an Italian company. We started in 1879 from Italy, and then we gradually developed the solutions, different solutions. Primarily, the first solution which we invented was in 1893. It was a very basic solution, Gabion technology, which we see the use of that solution pan across the globe nowadays. We basically are present in more than 130 countries across the world, and we have our the manufacturing units and the representatives in these countries. Have been doing projects in almost all the countries across the world. So today basically the topic which I am covering, it is related to the erosion control using the geosynthetic solutions. So I will be covering some details about erosion control, the research work which have been done, some solutions, and a newly developed design software which talks about erosion control, which is a new development, some of the case studies, and the how it is related to environmental sustainability. So basically, we all know that how how much soil is precious for life and for biodiversity. Basically, the vegetation is the essential need of the hour, which basically prevents any kind of soil erosion, where the roots gets the hold of the soil and prevent it from the erosion. So soil erosion basically refers to erosion of the top soils. It could be because of the wind, it could be because of the storm water, or because of the rain. So different type of soil erosions, basically it starts from a splash erosion in which the topsoil starts getting detached, and then there is a sheet erosion. Basically, this is generally due to overland flow process, and then there is some rills are formed,
These are basically the shallow channels, and then which it ultimately takes form of a gully. So these are the erosions, soil erosion, which we primarily see in the slopes, be it in the road projects, in railway projects, be it in mining, or in some of the hilly regions as well. So now basically we are more concerned about how to prevent this loss of soil, so that ultimately the slope failure should not happen, because after the superficial erosion, generally the slope gets unstable and there are a lot of chances of the landslides also. So we are basically committed in giving some long-lasting and innovative solutions. We have a innovation center in our in Italy, basically from where our parent company belongs. So we have been collaborating with top research institutes, with a lot of universities in these research innovations. So we are primarily, focusing on giving the sustainable solution which can help the environment, and basically which can help nature to grow. So we'll talk about growth of vegetation. So we had we approached Professor G. Bishti in University of Milan regarding basically the relationship between erosion control solutions and the vegetation growth. So basically, there are 7 key factors which are related to the vegetation growth. It could be a revegetation or a new vegetation. So these factors are primarily the penetration of the light. It should be proper. How much water is absorbed. What is the the shear resistance of that solution, which can prevent the topsoil from getting eroded. Then the weight. It should not get blown away from wind or from water. The uniformity of the solution and the roughness of the solution. So basically what we see, there are different erosion control solutions which are there. So there are some biodegradable solutions, there are some geosynthetic solutions, there are some composite solutions, a mixture of biodegradable plus geosynthetic solution, and of course there are other geotextile solution, part of geosynthetic solution. So basically the 7 factors which just told. So the University of Milan, the Professor G. Bishti, he basically had a detailed study about these kind of products or the solutions, how they behave when they are when there is erosion or the chances of the erosion. So on the 7 key parameters, what is the performance of these different solutions? So we'll see when it comes about light penetration, thickness, color, weight, water absorption. The biodegradable mats, because of certain factors, they are not good in everything. And then we talk about geosynthetic solutions or the composite solution, or basically the matte solution, again the geosynthetic ones. They are giving the highest performance when it comes to the erosion control. So basically, we developed this solution. We call it as MacMat. It is a synthetic made up of synthetic filaments and polymers which are tangled together, and this gives us more than 90% of the porosity. So sufficient sunlight can reach. Then it has basically a great shear resistance in the surface runoff or in case of wind, and it is perfectly suitable to be used in road projects, railway projects, in airports, or in other slopes, in mining or in other sectors as well. So basically, there was a detailed study which was done, and the performance of the MacMat along with the high strength geogrid, high strength polymers, and then along with the steel reinforcement also it was done. So what is the behavior? So on the graph you will see on the 7 parameters what is the behavior of these kind of solutions when they are being used over the slope. So we see that there is a lot of increase in the shear resistance when we include a reinforcement inside these kind of geosynthetic solutions. Reinforcement could be of a steel, or it could be from a high strength polymer geogrid as well. And the protection of basically the topsoil, it happens. Now we all know about the famous Russell equation, which gives us it is basically a model developed by U.S. Department of Agriculture, telling about the universal soil loss. So we have developed an advanced software how we can calculate this soil loss and what is the impact when we are using a solution for protecting this erosion from happening. So this solution basically have this software basically have the simulations which is without the use of this solution. This is the first simulation, and second simulation is when we are using this solution. So basically, there are different analysis and results when we talk about the 7 parameters, the K factor or L factor, C factor, P factor, etc. of the Russell equation, which basically gives the estimated average soil loss after calculation of all these factors. So if we talk about projects, how we can implement in the real life in the projects. So this is the evaluation done from a project. I will just come to the case study. So this was a case study from a project in Bihar in the Gandak River. So how the calculation of the soil loss can be obtained from the software, and after using of this MacMat along with the reinforcement, how we can prevent this soil erosion. These are some of the photographs from the project. Then second case study, it is from a basically dedicated freight corridor project in Rajasthan. So you can see on the left picture that there was a almost silty sand and almost no vegetation. But after the use of these geosynthetic erosion control solutions along with hydroseeding, which is basically an advanced version of mulches and seeds, which is sprayed over after applying of this MACMAT, and how lush the vegetation has grown over a period of time in this challenging conditions. Now this case study is from Tamil Nadu. It was from a NHI project. So you can see there were two slopes. The lower slope of having almost an angle of 79-80 degrees, the slope angle, and the upper slope with a gentle angle of 45 degrees. So in the lower slope, it has been protected using some soil nailings and MACMAT and hydroseeding. And over the upper slope where it was just the hydroseeding which was being done. So this is on the right side, you will see the lower right side, the photograph after the use of the solution. Another case study, this is from outside in Tanzania, in Morogoro Railway project. So you can see a lot of rills which have been developed because of the erosion, and because of this erosion, the tow drain have been filled all filled with silt and all the debris which have been coming off the surface. So how the solution was implemented, basically after doing the leveling and the scaling part. So the solution was implemented using the two I would say products, MACMAT R1, MACMAT 12.1, which was the need of the R according to the slope angle, different slope angle. So you'll see this is basically taken from a drone, this image. These are the solutions which are being adopted. And then hydroseeding is being done using a spraying machine. And see, after the lower part, hydroseeding is done on the slope part and how thick the vegetation has grown. So basically, we help all the clients, the consultants, the contractors from the planning stage, then building it, and then along with the design part. So it is basically covering the value of these sustainable solutions, which helps towards achieving of biodiversity or helps in life. So these products are basically uh, I would say long lasting. It can sustain 60 years of life also, or we can design it for 120 years also. So these are basically as per the UN sustainable goals, these products are they qualify and they help in reducing the carbon footprint as well. And why these solutions should be adopted is because of the ease of the installation, then I would say increased speed of construction and the improved performance. Yeah, that was all from my side. If there is any question, so please feel free to ask. Thank you. Thank you. We are
Thank
just a
you.
call away. You can always call us. Thank you.
Thank you. Now I request Mr. David, Asian Contact Limited, whose subject is unleashing multi-channel GPR. Now floor is yours.
Sir, mic है.
Yeah, please tell.
Hey.
Hi, so I'm going to just talk about sort of unleashing multi-channel GPR technology. But just of all, I just want to give you a first sort of introduction to where I work, which is Screening Eagle Technologies. So Screening Eagle, we're the market leaders in non-destructive testing equipment. So a lot of people here would have used our Schmidt hammers, rebar hammers, various other parts of our sort of ecosystem. But we also have a full sort of subsurface mapping part of our company as well. Over 300 employees operating out of sort of 3 global headquarters. And here's just a small section of our ground penetrating radar devices. So for anybody that doesn't know what GPR is, I just want to give you a little bit of an introduction as to what happens when we send these electromagnetic waves into the ground. So essentially, as we form over a target, or in this case, a pipe, we're able to form what we call a sort of hyperbolic shape, and that indicates that there's something in the ground. Now, just various different ways of visualizing data. So typically, we have what's called an A scan, which is a single signal that's sent into the ground. When we have a few of these going along a certain path, we create a B scan. And when we've got lots of B scans put together, we can actually create a C scan, which is a sort of 3D visualization of what's going on in the ground. Now, sort of multi-channel GPR isn't new. It's been around a while. As we can see here, various different makeups of different multi-channels. One that's been pulled in the bottom left, and then various different designs where people have sort of manufactured these or put them together themselves. And this is sort of the resolution of what you can get from GPR. Okay, so along the top, we have 3 different versions of the same data set. Okay, so for the first one, this is looking at rebars. So A is a single channel GPR. B is multi-channel. Okay, and then C is the actual image, so uncovering it. Okay, so from single channel data where we can't see very much, as we sort of move down, we can then start actually making out exactly what it is that we're looking at, including these tree roots or these very small metallic objects. Okay. So this is on to the unleashing multi-channel GPR. So we'll start with the leash, which is pretty much the status quo as it is today. So for lots of different applications, you need multitude of different technologies to be able to investigate airfield, structural, utilities, geophysical surveys. And there were various different bits of technology that we use for those specific applications. What Screen Eagle have done is we've developed one system for all applications. So you essentially get the hardware, and then the antennas are interchangeable. Okay, so you can swap out the antenna based on application. So it's a little bit like a Formula One pit crew. As soon as you finish with one application, you can pull in, quickly swap the ties in this example, but for us, antenna arrays, and then move on to the next application. Okay, so that's unleashed the technology to be able to use for a multitude of different applications. Now let's look at the status quo of sort of imagery. Okay, so this is a late 90s single channel radargram. Okay, so this is what we'd typically see from a single channel system. As we move into the 2000s, we can see sort of the technology you'd see with a multi-channel device. And this is typically what we get today, 2024. This is what you'd see. And then this is what we can see with our system. Okay, so our system's unique on the market in terms of the design and the makeup, but here we can see all the cracking that's on that surface. This is 25mm resolution. We can see 1 centimeter resolution, so we can pick up all of that surface cracking on highways, bridge decks, those sorts of things. We can see sort of geophysical, what's going on below. So this is a little bit of, for this instance, rebar. So this is sort of 10 centimeter spacing. Here we can see 100 centimeter spacing, so 1 meter below the ground, 1.5 meters below the ground, and here 2 meters below the ground. This is actually an archaeological site that we're able to see using our technology. And what you'll notice from this 3D image, we're not really looking at radargrams anymore. It's almost like a photograph of what we're seeing at that different level, an X-ray, if you like. Okay, so now we're sort of unleashing that data, and we're sort of limited now by data volume and what it is that people want to use this information for. What we do know is that mapping at scale is an absolute must. We've got a lot of roads, bridges, and highways that need to be mapped. And with this system, we're able to simply drive, go into the likes of an underground car park like this. In this example, it's an underground car park, but it could quite easily be a tunnel or somewhere that's quite sort of built up where we don't really get GPS positioning. But utilizing our system, we're able to still accurately map no matter where we are. So even going through an underground car park, we know exactly where we are. The other side is being able to map and get that real-time visualization as we go. So this is the example of our vehicle-based system. So as we're driving along, we get this real-time feedback. So we get the real-time 3D tomography at the top, and below we can see that radargram forming at real time. Now this thing, depending on application, can be driven at highway speeds, so as fast as you're allowed to go on the highway. And as I said, at the moment the industry is limited by the amount of data that we're actually processing. For us, we have this parallel processing, which allows us to switch on as many machines as needed to actually process this information. So we're not limited on file size, distances, or anything like that. So if you wanted to map entire cities, we could do that. So here's just some examples here. And here we're looking at sort of more diagnostics and monitoring. So as I said, we're able to map cracks on asphalt layers. So this one's actually 6 centimeters below the surface. We're able to pick out asphalt layers. So if we were looking at thickness of asphalt, we can actually map all those out. We're actually able then to create these pavement thickness maps. So we can look at where areas are likely to have sort of eroded, or we have voids or things like that below the surface, where we then need to plan sort of remedial work then to repair them. We can identify potential voids or cavities for water retention, so more for geotechnical investigations, sinkholes, things like that, that are sort of happening all around the world. We can actually use this technology to identify where they are and how far below they are below the surface. We can actually produce these deterioration maps as well. So this is a hand push system over a bridge deck. So here we can quite clearly see all of the rebars. What we can actually see on this bridge deck, which is quite nice, is here we can see the first layer of rebar, the post-tension cables or attendants within inside the bridge, and we can see the second layer of rebar there as well. Okay. And what we can do using the ATSM standard for bridge deck monitoring is we can actually produce what's called a deterioration map. So based off of the amplitude response from the rebar, i.e. a full rebar will give us a certain signal. As that rebar starts to corrode, it will give us less of a signal. So we're able then to produce this heat map over the top of areas where you'd then need to go some deeper investigation, cut and core over those areas to remedy those errors. And just another example of some of the surface cracking. So this is 6-7 centimeters below the surface, and like I say, with the level of detail with this antenna, it's almost like visually seeing an X-ray of that image. So there we go. So that's sort of unleashing multi-channel GPR. So one system for lots of different applications, unprecedented image resolution, with the ability to map with unlimited data volume. Thank you very much.
Thank you, Mr. David. Now I request Mr. Rishabh Garg, International Business Development, Good Luck India Limited, to present his use of certified safety barrier at roadside. Now, floor is yours. Please be in time and concise.
Good afternoon, everybody. Today, the topic for our presentation is the vehicle restraint systems, specifically safety barriers, the technical classes as per EN 1317 or NC HRP 350 or MASH. Today, the problem is the 40% of the accidents on the roads are run-off road accidents where the driver often leaves the road outside the shoulder or the center line and has a two-way road accident on the other side, or usually crashes with a hazard on the median of the divided road. A large number of crashes on the road today are run-off road crashes. Therefore, the design of the road needs to be optimized to contain the vehicle which is running off. The first principle of hazard management should be to design roads to keep the vehicle on the road and prevent the vehicle to become errant or run off the road. What is a roadside hazard? With which it's any infrastructure element which is placed in the neighborhood of a road that once reached by an errant vehicle may cause damages to the occupants or to the other users, other cars on the road, or to the third party, like the buildings, schools, any obstacle like a fixed object, poles, electricity lights, walls, ditches, any slopes, embankments, other other obstacles like water courses or maybe railway lines are defined as the roadside hazard that the vehicle may encounter while its journey on the road. We are Good Luck India Limited. We design, engineer, and manufacture vehicle restraint systems like pedestrian parapets, which are performance tested, transitions between different kind of safety barriers, approach and terminals, crash cushions, also called impact attenuators, steel safety barriers, or as widely called in India, crash barriers, safe poles, aesthetic urban parapets, motorcyclist protection devices, and also bridge parapets. We are listed on the equity market, and we have been designing, engineering, and manufacturing since over 20 years now. So as we are very well aware that 40% of the road accidents are due to the vehicle which is going off the road, how can we contain the vehicle on the road? We can use vehicle restraint systems. What kind of vehicle restraint systems are available to avoid these kind of accidents? One is the safety barrier, which could be a single-sided safety barrier, which is typically used on the shoulder, a double-sided safety barrier, which is typically used on a median, and a parapet, which is used on the bridge. Other kind of vehicle restraint system that can be used are crash cushions, terminals, which are the end treatment to the safety barriers, transitions between two different kind of safety barriers, and motorcyclist protection devices. Why do we need certified safety barriers today on the roads to address this problem? Traditionally, safety barriers have been introduced since 1950s, and in 1950s they were originally based on engineered design, where the barrier was not evaluated using a full scale crash test, but only based on engineering designs, and that too with very light vehicles. They were not designed to perform for heavy vehicles. The social claim for a higher traffic safety standard demands that any vehicle restraint system installed on roadside should guarantee its performance, that it should be only validated with a full scale crash test. Today, the fleet of vehicles does not only require or does not only demand one unique barrier, but a range of different safety barriers as per different containment levels and working widths, which are available on the highways and the roads. More and more countries, as we speak today, are adopting to the use of certified safety barriers, but not the traditional ones. Now, what is a certified safety barrier? It's a system which has been evaluated under a full scale crash test by as per any international standard. The two main international standard, as we are aware, are the American and the European EN 1317, and it is also approved by a accredited or a recognized third party. As we already spoke about, what are the main existing standards? The European EN 1317, and the earlier in America, USA, it was governed by US NCHRP 350, but it has been replaced by MASH. It is usually the governing body is American Association of State Highway and Transport Officials. What is the difference between the two international standards available under which we can perform crash test or as per which we can use the safety barriers on the roads? The main difference is that the US standard only approves the performance of the safety barrier, but does not certify any safety barrier as per the production of the safety barrier or the installation of the safety barrier on its own. However, the safety barrier, which is designed and tested as per the European EN 1317, is being certified under the competent authority CE, and the scope also includes the certificate of performance, certificate of production, and also certificate of installation. So as now we will talk mainly about the European EN 1317 certified barriers. What is a CE certified safety barrier, or what is the safety barrier which has a CE marking? It is any safety barrier which has a performance, which has a performance under the vehicle impact, its manufacturing and installation has been in conformity with the requirement of European norms EN 1317 and certified by a EU notified body, which is basically the CE. How is the conformity evaluated? The performance under vehicle impact is evaluated with the impact test, technical description of the barrier, and also the verification of the technical description of the barrier, which is also provided in the crash test report. The manufacturing, the body usually conducts inspection and audit of the factory which is manufacturing the safety barriers. Installation, if the safety barrier is installed as per the specimen of the sample which was crash tested earlier. What is a crash test? It's where the 40 meters of safety barrier is placed under testing, and it is tested with the vehicle which is full scale crash tested, like car. It could be a truck, it could be a bus, or it could be an articulated truck. Also, there are 11 types of crash tests which a safety barrier can go through, ranging from a 900-kilogram car to a 38-ton truck. The speed varies from 65 kilometers per hour to over 110 kilometers per hour. And it is also impacted under different angles, which could be 8 degrees, 15 degrees, or 20 degrees. How do we compare two safety barriers which have undergone through the same crash test? There are basically four performance parameters under which the safety of the barrier can be examined. The four parameters would be containment level, impact severity, system lateral deformation, and redirective capacity. What is a containment level? The containment level for the capacity of a system for vehicle retention in a controlled manner is the containment level. What kind of containment levels are available as per the EN 1317? It could be N1. N1 would be the containment level for a barrier which has accepted the crash test, which is TB31. N2 would be the TB32 plus TB11, which has performed well under these two crash tests. When we go from normal to a higher containment level, it has accepted crash test of TB61 and TB11. This presentation will be available online. So if you can want to have a look at different containment levels, you can have a look. These are the different parameters which define the two different safety barriers. So while choosing what kind of safety barriers to be installed on your highway or the road, the two main criteria will be the working width and the containment level, which and also the redirective capacity. So when the vehicle comes under the crash test with the safety barrier, as you can see on the presentation, there's a red line. It should redirect itself towards the flow of the traffic. It should not redirect itself to the oncoming traffic. Here we have already spoken about the EN 1317. Let's talk about US MATCH, which is the second standard that it is used worldwide. Majorly, they have different containment levels, different impact conditions, different type of vehicles for which they are crash tested, different evaluation criteria, and different deformation criteria as well. So is it true that if we are using one standard, we cannot use the other standard? No, we can use both standards together by using the maximum safety of each crash barrier or the each product and compare it as per this table. So as per today's session, the crash barrier should be as per the situation of the road, as per the containment level, as per the working width which is available on the road. If you have any questions, thank you.
Thank you, Mr. Rishabh. Now I request Mr. Pratik Sen, General Manager, Messrs. Jindal Steel, to present the topic Building Sustainable Infrastructure with Stainless Steel, brief overview and case study. Mr. Pratik Sen, now floor is yours.
Hello. Very good afternoon to the chairperson of this session, Meghwal sir, co-chair for the session, Mishra sir. Very good afternoon to you, and ladies and gentlemen. I'll be presenting. So the topic of today's the next 10 minutes is building sustainable infrastructure with stainless steel. Some brief overview and some case studies. To talk a little bit about the presenter, like me, myself, and my colleague Bose. Bose is there in the audience. He's an MBA in Advanced Construction Management from NICMAR Pune, Master's in Structural Engineering, and has done his Bachelor's in Civil Engineering from Satyabhama University in the year 2011. And I'll just try to skip this. To talk about the brief overview, yes, what are we primarily addressing? As the American journalist Jane Howard has rightly said, that new links must be forged as the old ones rust. In this next slide, you will see that there is a figure which is mentioned. Yes, it is the year 1986 that I have mentioned over there. And, many of you could have been in your college days. Some of you were probably not born. Some of you were probably doing your initial, maybe your first job. You're there in your first job. But the unfortunate part, in this very year, it was the first recorded history of a major bridge failing, which is the first Mandovi bridge, which failed within 15 years of commissioning. And the only reason was corrosion. So, roughly, it is about 4 decades that Mr. Corrosion has been making the lives of various civil engineers hell. And even you all must be attending various seminars in India or overseas, and still we are discussing this issue. Well, the failures is just not that it is in India. Yeah, this is a bridge failure that happened at Dresden, Germany, just couple of months back, and this was 100-meter span, 100-meter span which suddenly collapsed. So far, I have not discussed about what could be a possible cost impact for when things go wrong. This is one example wherein this was constructed at a cost of around 34 crores in the year 2017. But because of some reasons, it has become unserviceable and which will probably be demolished and reconstructed. And when you do a reconstruction, definitely the cost will not remain as 34 crores. It will be 34 plus 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 plus. Uh, then I also tried to figure out that what could be a rough estimate of the maintenance cost, because again, maintenance cost is something, yes, it's defined in some codes and all, but to take a reference, like from, if I can have a reference, state of a reference of what could be the maintenance cost. This is a tender, a bid notice that had come up. I think it had come up in the year in September again. Over here, we see that this is tender for a 48-meter bowstring girder, steel span, very close to the coastal area. This is Kandla in Gujarat. And here we see that the cost of the material construction or the bridge construction cost has been pegged at 65 crores. And the maintenance cost for the first 3 years, I'll repeat, it's for the first 3 years, is about a crore. Now, if it is 65 crores of construction cost, let's just approximate that it is 50% for superstructure and 50% for the substructure. Then the maintenance cost for the first 3 years is approximately 3%. So you have a cost of 1% per year for the maintenance. Now, if something goes, if this is an ideal case wherein everything goes perfect, something goes wrong, and this cost will definitely increase exponentially. So, likewise, Ministry of Road Transport and Highways has very rightly come up with a circular wherein they have emphasized on the use of stainless steel in construction projects. But one area which I would like to highlight is after the issue of this circular, somehow people started, or the fraternity started thinking that this is only restricted to coastal areas. But I would just like to highlight, so yes, coastal, 15 kilometers from the coastal areas, that is the last part of the circular, which is pretty clear. But there is a section which is actually mentioned above, which is extreme environment exposure as defined in IRC 112. Now, if I refer to extreme environment exposure as per IRC 112, it says that the definition in table 14.1 says that it's a bridge which has cyclic wet and dry cycles, concrete exposure to tidal splash and spray zones in sea, concrete in direct contact with aggressive subsoil or groundwater, concrete in contact with aggressive chemicals. Now, if we are just trying to identify which are the zones which we can actually segregate these 4-5 areas, yes, exposure to tidal splash and spray zones, very much coastal area, but concrete in contact with aggressive chemicals may not be mostly applicable to non-coastal areas and rarely applicable to coastal areas. Cyclic wet and dry cycles, it is applicable to both coastal as well as non-coastal areas. And lastly, this direct contact with aggressive subsoil or groundwater, mostly applicable to non-coastal areas and maybe or rarely applicable to coastal areas. So, in crisps, there are other factors which affect corrosion is temperature variations, humidity, and pollution. So, being a market leader in this niche, in this product segment of stainless steel, we have come up with some focus grade of stainless steel, and to talk about their composition. Why am I talking about composition is, the first thing that happens when we go out and meet with people, and they say that बहुत महंगा है. Like the basic reason is we actually put in some rare metals into the steel, into the stainless steel that we are doing, and make it stainless. So, as per definition in the global scenario, any steel which is having 10.5% plus chromium is ideally a stainless steel. So, chromium makes it is the basic building block for stainless steel. Nickel adds to the ductility and the weldability, and molybdenum is the delta when it goes for corrosion protection. So these are, I've just shown the major contributing metals, and you like people with the in the metallurgical background, you can cross check. It is these metals are actually rarely available. China, if you say that they're the market leaders in stainless steel production, that is because they hold maximum reserves of all this. And we are trying to just, like match up with producers in China. Now, I'll focus on stainless steel grades for bridge applications in particular. The first two that you see, that is IRS 350 and IRS 450. 350 stands for yield strength of 350 millimeter MPa, and 450 is 450 MPa. The good thing is, up to 50 millimeter of thickness, it retains the same yield value. So that is the most positive part. Then you have the duplex variant and the lean duplex variant. On the last column, that you'll see that there's a PREN number that's mentioned. That PREN stands for pitting resistance empirical number. Yes, there could be a school of thought who says that and it is a direct measure of the corrosion resistance offered by that metal. So the IRS 350 450 is having a PREN number of 11, so people may think that it's not that corrosion resistant. But obviously we have to take a mix and match of, like the more sugar you add, it gets more sweeter, and which boils down to the cost. So IRS 350 and 450 are approved grades. 350 is an approved grade by the railway. Like RDSO has a very clear specification for IRS 350. So we have done the basic comparison of IRS 350 with respect to corrosion, with respect to fatigue behavior, and with respect to moment retaining capacity. Top left quadrant that you see is corrosion loss. We have compared with carbon steel and weathering steel, and IRS 350 CR is stainless steel. It is 50 times more corrosion resistant. This is based on some salt spray test for 8 weeks that we had conducted. Then on the right side, as you see, that the fatigue behavior, the IRS 350 is equivalent to ASTM 709 50 CR, and you see that the fatigue resistance is pretty nice, and the remaining moment retaining capacity. Here we have also compared carbon steel, weathering steel, and corrosion resistant, meaning stainless steel. To give you a direct impression of how it is, there is a picture on the left bottom quadrant, wherein you have, these are basically checkered plates, which are also of the same grade, and you see that there is corrosion that has happened. I'll skip these standards and quickly come to the case study. I have compared the case study for IRC SP120, wherein we have a similar 30-meter center to center span, deck width of 12 meters, girder configuration similar. Then RDSO standard drawing we have compared, and steel span we have compared. What I'll do is, I'll not focus much. I'll directly go into the results that we have yielded. Okay, so when we compare mild steel and stainless steel, say for the first example, which is the composite girder as per IRC SP 120, we see that there is 24% material savings. Even for relatively conservative design, which is RDSO, which usually RDSO does, there also we can yield and savings of 11%. Remember, both the drawings are approved by RDSO. Then the deflection of steel, there is 10% less deflection because of the modulus of elasticity value. And when we compare stainless steel rebars, there is a 13% reduction in area of steel when we use 650 grade or 600 grade stainless steel. These are the offerings from us. Status of RDSO, the status of drawing from standard agencies. I'll quickly go into the project references that we presently have, which is Karyappa flyover. This is a flyover in Mumbai, which has SS pylons, which is around 54 millimeters in height. These are some images from the fabrication workshop, and you can see the first thing is, please conclude, sir. Okay, sir, I'll just quickly close with the last slide. So future of bridges and the role of bridge owners, it should be lightweight, optimized use of material, it should be sustainable, reuse, recycle wherever possible, and it should be intelligent, health monitoring and other AI tools. Thank you so much.
Thank you, Mr. Pratik. Now I request Mr. Subham Kalore to present his paper, and subject is technology for durable payments. Please strictly follow the times. Question regarding the presentation can send the return or paper circulate.
Good afternoon, everyone. So, first of all, I would like to thank the chair and co-chair and IRC for giving this opportunity to talk on the title Technologies for Durable Payments. So, on the left-hand side, I'm showing a photo where a payment is constructed 5 years back. And as you can see, it's adjacent to a sea. And it was constructed in Karnataka. And the photo is taken few months back in a rainy season. So whether are we looking for payments which are performing similar to like this and are looking excellent condition, or whether are we looking for failure something looks like this. Such kind of failure happens due to the impact of water to the pavement subbase layers as well as to the bitumen stripping. So in short, water impacts the subbase as well as the bitumen layers. Now, what we are looking for? We are looking for technology for longer life pavement. So our future infrastructure should look for the climate resilient infrastructure, durability, as well as sustainability. So we have solution for the bases, sub-bases, subgrades. That is, we have stabilized and water resistant high retain strength in the optimization of the upper layers. We have the solution for our prime coat, track coats, as well as the bitumen layers that I'll be discussing in future slides. So what essentially we are doing, soil layers, we have two chemicals, that is the additives, terrasil and zycobond. So we are essentially transforming the soil surface from hydrophilic to hydrophobic. Hydrophilic means they are water loving. They have the OH group on their surface. So that leads to water loving nature. So they just absorbs water. Due to absorption of water, we all know there's a degradation of the material. But with the application of organosilane technology, that is our terrasil compound, we actually transforms the silanol group, that is a OH group, to a alkyl siloxane surface, that is SiOSi, and there's a organic compound on the surface. So this leads to water repellency on the soil surfaces. That leads to decrease in the water absorption, and the soil surface simply repels the water. We have another compound that is acrylic copolymer zycobond that enhances the cementitious bonding, and it enhances the bonding that takes place due to the cement also. Now, the synergy of the terrasil and zycobond is shown in this figure. So terrasil essentially gives us the moisture resistivity, whereas the zycobond gives us the modulus enhancement as well as the nanobonding. Now the combination of modulus enhancement and nanobonding, we get the basic parameter that we consider on our pavement, that is the UCS. So usually with a typical dosage of 1 kg of our compounds, we satisfy the requirement of 4.5 MPa. Now the combination of moisture resistivity plus modulus enhancement, we can have higher retained UCS, which is the proxy for the impact of moisture. And with the combination of moisture resistivity and nanobonding, we get a higher durability cycles. So a design should be based on how many cycles it takes for the 14% loss, not like for 12 durability cycle, how much is the weight loss. So the combination of all these six, we get a longevity for the stabilized basis. It reflects in the enhancements in the fatigue life of a pavement. Now, I'm just showing few of the extreme cases where we have constructed with stabilized pavements, where the first one is in the Uttar Pradesh full depth reclamation, where you can see water bodies on the adjacent side of the pavement. So it was constructed last year, but right now it's performing extremely well and satisfying the all requirements. The second pavement, the second photo that I'm showing is from Jammu and Kashmir, where you can see heavy snowfall and rainfall along this pavement, and still it's working very satisfactorily. And this was constructed in 2018. So further, we have also done a lot of full depth reclamation pavements in Uttar Pradesh, and we have evaluated them structurally based on the falling weight deflectometer. So we have adopted a standard approach by using co-op machine, and it consists of application of dynamic 40 kilonewton load, and then we measure the surface deflections using these standard offsets using geophones. Now the data looks something like this. I'm trying to just show candidate models and trying to explain how the payments perform. So in this, you can see a deflection on the x-axis, whereas the chainage on the chainage on the x-axis and the deflection on the y-axis. So these are few deflection bows that I'm showing. But here the interesting point to note is that we see a huge variation in the deflection bow. This is due to we do not have control in the full depth reclamation on the material that is coming. It is all in situ, it is all blind. So that's why you see a huge variation. And therefore, it is very imperative to consider innovative technologies so that we can reduce such kind of variations that comes into picture. But overall, what you can see is the D naught deflection, that is the maximum deflection under load, varies from 0.1 to 0.5 mm. In extreme cases where there is a localized failure, it even goes to 1 mm. So we, using those deflection data, we have done the back analysis and tried to find out what is the modulus for the base layer, for the bituminous layer as well as subgrade layer. So this figure shows the analysis done for the 20 roads. Here we have also shown the pavement composition, the dosages that were used. Overall, what you can see is the modulus for the FDR base layer is much higher than what was considered in the design. The modulus varies from between 1000 MPa to 4000 MPa. The variation is due to the high variability that we encounter in full depth reclamation. Now, coming to the bituminous side, as I said in my previous slide, like we are converting the soil surface from hydrophilic to hydrophobic. Actually, we are converting it to oil loving. So now, once we apply the same technology for the bituminous layer, the bitumen is actually going to get coat very nicely and uniformly over even the fillers, even the aggregates. So this technology is actually we are combining the organic and inorganic by using alkoxycycline with an organic group. So this technology is compatible with SMS, PRM, PMA, as well as SMS technology. We have combined WMA and anti-strip, which goes in this zycotherm, and we have higher incorporation of RAP is possible. We have excellent salt tolerance, and eventually this gives us the improved workability. So I'm just illustrate the workability through this video. Just okay. So next we have the tack coats. So tack coats are the track. We have the trackless higher interlayer bond strength, where we try to shift the failure plane where from the interface to some other failure plane. So that gives us a very high interlayer bond strength if we use a nano tack for the tackless coats. Next, we have the prime coat, which is a quick setting and deeper penetration. And this was the video which was showing the how uniform coverage we get, and it is a deep penetrative showcasing. So way forward, paved bitumen mixes PMBs, CRMBs, and VG grades with WMA and anti-strip prevents raveling and potholes. We need to build stabilized water resistant soil aggregate bases, subgrades, and shoulders with lesser material using existing crust with longer life and smooth roads. Overall, this technology enhances asset life and reduce maintenance. Uh, Thank you, and please visit us at stall number B1. We have the live samples. You can see the water repellency and the different technology that we are presenting. Thank you very much.
Thank you, Mr. Subham. Now we can take the question answer, if any.
Uh, I should congratulate all the speakers. They did complete within their stipulated time frame of 10 minutes. And we had a varied range of topic out here, which started with the ground penetrating radar. Then we went to the base layer. Then we went for the bituminous pavement. And ultimately, we went to the superstructure where uh, stainless steel had also come up. Yeah, please, sir.
आप माइक थोड़ा पास में ले
Zydex. I have a question for Zydex. Yeah. How is this Zyco bond different from Zycotherm, which we were using earlier?
Yeah, Zycotherm is for the bitumen mix, whereas the Zycobond is for the soil mixes. Whereas it works with the cement and it gives enhancement in the bonding.
I have a question with Zydex. How the Zydex material is resilient to the soil and will not affect the our mother earth. Have you any
Yeah.
investigation or practical field analysis done on this, or we are going without any field analysis or effect?
These chemicals are toxic free, environmental friendly. We have the toxicity analysis done. So this actually does not hurt Mother Earth. And these are eco-friendly chemicals. Sorry.
Lifespan.
Mike, please.
Yeah. So the chemical reaction is actually permanent. So the life actually depends on how much load you're putting, how much repetitions are going. But it is expected that at least we get an enhanced life and double the what we are expecting.
One doubt, like this, you said it is a nanotechnology.
Yeah.
So how do you ensure that all the particles are treated with this nanotechnology? Like the soil matrix is a very huge and very, very complex material. How can we ensure that this is coated everywhere?
So that is nanotechnology itself, like it's a nano size. So you can cover maximum bonding between the given grain size. So if you have a nano size, that means you can, given with the same dosage, you can cover maximum surface area. If you have a coarser size, that means you have limited bonding that happens. So that is the advantage of nano bonding.
With permission of chair, can I add a line to what Shubham is saying? Thank you very much. Sir, the point is you cannot coat all the particles of the soil. That's for a fact. But what is very important is if we are able to coat 80 to 90% of the particles. Now, in 1 cubic meter of soil, you have 10 to the power 15 particles in fine soils. Now, the whole point of nano is that the intensity of the material is so high that you are able to coat maybe 50 or 60% of the material. In that kind of a case, if the moisture ingress is arrested to the extent of 90%, you are not disturbing the dimensional stability of the structure. Even if the water comes in, it's a one-way barrier. Water cannot come in, moisture can escape out because water in nano form is only 0.18 nanometers. While the pore sizes are higher. Once it is made hydrophobic, the water drop sits like a contact angle because water drop is actually in micron size. So, to answer your question, we can hypothetically take the dosage to a level where we can make the whole stabilized base waterproof. The question is, will the asset owner allow us to look at change in design? If the design is opened up, we can technically give you a base which survives for 100 plus years.
Thank you. Now I request co-chairman sir, Mishra ji.
Any further questions or should we sum up? And I have just put in almost 10 years in Gujarat Metro Rail Corporation also. So I will be requesting Mr. David Fox from the Asian Contact, because we had to deal with very basic GPRs. It was an old city, Ahmedabad, almost 60, 70 years old now. And suddenly we could not detect the utilities. So the basic GPR instrument is also very good in locating the ground utilities which are uncharted. You never know what is there. So I will request his company to come out with a more indigenized, less sophisticated version also, which can be useful in our, because whenever we go for expansion of highways or any big infrastructure projects, especially in the city areas, so you encounter n number of uncharted utilities, which everybody has forgotten. So GPRs are there to stay. And I'll congratulate all the speakers who have, I think this is a very real eye-opening session where we as a traditionalist and conventionalist are woken up, and it's an eye-opener for absorbing the new technologies. So my congratulations to all the great speakers, and that too in maintaining a very tight schedule of 10 minutes. So thank you all. Thank you so much. Yeah.
Thank you, Mr. Co-chairman, Mishra ji. I congratulate all the speakers and their presentation was very good and wonderful. All these private stakeholders are the partner in the road construction as well as building our infrastructure. Now it is time to have a lunch. All are eagerly waited for lunch, waiting for lunch. So I conclude with my remark that these presentation are very wonderful, especially on the presentation by the Niranjan Sarkar about the life of payment, how payment can be life can be increased, and with the uh, less cost of maintenance, etc. And today's scenario as we have to save our mother earth, therefore structure must be resilient to the environment. Similarly, the presentation made by the McAfee solution about the erosion control using geosynthetic, these are the need of the hour, as there are many example of soil erosion that have uh, stopped our highway and traffic has been held, and many casualty also occurred in the past. As the climate is changing and we must use the new technology as technology or material in the our construction. Similarly, the presentation by Mr. David, ground penetration radar solution, we must use the technology, but with the technology, our experience as we have gained in the field must be collaborated so that we reach at a conclusion. So with machinery and software, we must use our experience. Use of certified safety barrier by uh, roadside by the Mr. Rishabh Garg. We have a IRC code about this, and which is under consideration of the council side. Most probably it will be discussed, and we have all major issues about the safety standard have been incorporated in this. And if we save a one life by the road safety technology, road safety equipment, etc., then we will save our future generation. If one life saver, we are very much on the very good side, as we have almost 1.7 lakhs fatality in the India by the road accident, and which is almost 10% of the world. So road safety consideration, and I think all these manufacturer should attend our road safety standard, and they should manufacture as the standard, not as a regular, so used as uh, can be no safety standard. I also, thanks to Mr. Pratik Sen, who is whose presentation was about the stainless steel using in the building in the infrastructure, such as coastal structure, and where our climate is extremely uh, corrosive. So we are going through the stainless steel bridge, as more also issued a circular about the use of stainless steel in the bridge construction. And Zydex, we have all familiar about the construction material used as a now I thanks to all presenter, as well as the ladies and gents present in the hall, who are very very good, and all the question answer, if any, they can refer to the concerned presenter, and they will share their email address or in the presentation, or in the IRC coming journal. Thanks to all.
थैंक यू सो मच सर। और अब मैं मोमेंटो और बुके देने के लिए मंच पर बुलाना चाहूंगी पीएस बघेल जी को और जे आर राउत जी को कि वो मंच पर आए और हमारे सभी अतिथिगणों का सम्मान करें। मोमेंटो के साथ सर आपको भी रुकना है। श्री डी आर मेघवाल जी, सेक्रेटरी पीडब्ल्यूडी राजस्थान। Co-chairman Shri P.J. Mishra ji, Chief Engineer, R&B Department, Gujarat. और अब मैं प्रेजेंटर्स को बुलाना चाहूंगी जो प्रेजेंटर यहाँ पर हैं मौजूद, और उनको भी स्मृति चिन्ह और बुके देकर सम्मानित किया जाएगा। सबसे पहले मैं मिस्टर नीलांजन सरकार जी से रिक्वेस्ट करूंगी कि वो इस वक्त को, आज के इस दिन को यादगार बनाने के लिए, खास बनाने के लिए चेयरमैन और को चेयरमैन सर से स्मृति चिन्ह और बुके प्राप्त कर रहे हैं। मिस्टर डेविड, छत्तीसगढ़ी परंपरा और संस्कृति से ओतप्रोत ये मोमेंटो दिया जा रहा है और इसके बाद मैं बुलाना चाहूंगी मंथन चौहान जी को। मंथन चौहान जी। इसके बाद मेरा आग्रह है मिस्टर ऋषभ गर्ग जी से कि वे आए और स्मृति चिन्ह और बुके ले चेयरमैन सर और को चेयरमैन सर से। मैं रिक्वेस्ट करूंगी मिस्टर प्रतीक सैन जी से भी कि वे भी यहाँ पहुंचे और अपना स्मृति चिन्ह और बुके प्राप्त करें। मिस्टर प्रतीक सैन। मेरा आग्रह है इसके बाद डॉक्टर शुभम कालोरे जी से कि वे भी हमारे चेयरमैन और को चेयरमैन सर से स्मृति चिन्ह और बुके प्राप्त करें। थैंक यू, थैंक यू, थैंक यू सो मच सर। आप सभी का बहुत बहुत धन्यवाद और अब लंच का वक्त अब है और इसके बाद हम दोबारा मिलेंगे 2:30 बजे। 30 मिनट का लंच ब्रेक यहाँ पे दिया जा रहा है आप सभी को। हम फिर मुलाकात करेंगे यहीं।
Thank you so much. My cards. Take it. सामने सामने आ गया ना बहुत सामने आया या ये? सामने आया सब सामने चले हैं सामने सब हाँ चलिए
ठीक है सर।
PS5 का फोल्डर।
सर लगा के तो चल जाओ आप।
Hello.